Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z, as well as Anti. Because Anti's with us, we're going to be front-loading the podcast with some of the more threat intel-related topics. So we'll jump right into those, because Anti's not going to be with us for the full episode. He's going to be with us for about probably like 20 or 30 minutes or so, I'm guessing. So we'll jump into the first topic he wanted to bring up, which is Cognizant suffering Maze Ransomware cyber attacks. So, Anti, would you be able to jump into that one? Because I didn't get a chance to look at that one too much due to some other topics. But I know you wanted to bring this one up, so I'll let you jump into it.
Yeah, give me 1 second to pull up the link here. It's having a little bit of technical issues. But the Maze Ransomware, for anyone who's not aware of what this is, why it matters. So Maze Ransomware is one of the groups that is pretty prolific right now. They're one of the first groups that basically, once they hit you with ransomware, they would post your company's information on their little website and then force you to pay because all your information's exposed, right? So it's another type of ransomware. They don't just encrypt everything, but they also publish it until you pay them. So what's fascinating is they've actually spawned a whole bunch of recent ransomware variants that have caused them to change their way of thinking. So things like FLM and NEMT, I'm sure these all sound like archaic names to some people, but essentially it's kind of changed the business model of how ransomware is working at present. So Maze Ransomware recently hit an organization called Cognizant, I believe. I've not used them, so but I know that they're pretty large, and so I thought it was fascinating to see that even these huge kind of IT organizations that no matter how many preparations you have in place, right, especially for an organization that manages other people's infrastructure, the risk of being hit by something like ransomware is pretty steady. And, are you guys kind of...
So I want to bring up a question with that. It seems to me like the standing recommendation has generally been to just pay the ransomware. That ransomware is generally at least you pay it, you do get your content decrypted, and you're good to go. Has that been true, or am I misinformed?
So it's a little bit of both, right?
Because I thought the FBI had given the advice to simply just pay it.
Yeah, they definitely. So you'll hear the InfoSec industry be like, "Don't pay them, you're paying criminals," and so on. But the FBI, they've admitted that basically, what are you going to do, right? So yes, realistically, if you want your information decrypted, you're going to have to likely pay. Most of these ransomware variants, people haven't figured out, it's just encryption, you know what I mean? So it's secure in its sense that the way they're going about it, usually with two sets of keys, you're not going to be able to decrypt that content yourself. And the hard part is, even a third party company, they talk to the threat actors or whatever the hell you want to call them for you, it doesn't change the fact that your crap's encrypted. So, the hardest part actually that most people deal with is not even paying for it because it's trivial for hundreds of millions of dollars, a company that earns that much. It's actually that the decryption itself, right, takes months because it's slow and they're usually pretty crappy. So that's the caveat, is that even if you pay them and you're losing, I've known some organizations lose 3 to 5 million a day because everything's encrypted. It doesn't, it doesn't. The sad part is, even if you pay it, it still takes 2 months. You're now losing, in excess of, hundreds of millions of dollars. Even if you pay them,
Fair point on that. I was more wondering if it was really necessary to publish the information to encourage payment, because it seemed to me, as somebody that hasn't been, impacted by ransomware, haven't been involved with a company that's been impacted by ransomware, it seemed to me like generally they were paying it, so you didn't need further encouragement to pay. So it just seemed like that extra step just seems unnecessary to me.
I think it's because nowadays, you get some organizations that will go and publicly say, I'm not going to pay this, right? So it's more of incentive that if you want the trouble to stop, this group specifically, Maze, I'd have to pull up their website right now, but they have it where there's a group that I think it was compromised back in January, that refused to pay, right? And even though they refused to pay, this group, the Maze group, has still continued to kind of trash talk them and tell them that, this group doesn't care. And that, they've made it a point that it doesn't just go away because you don't offer to pay. The whole reason for that is they'll continue to post your information, and, the legality of it, of having that information out there, kind of puts you in a weird spot, right?
Yeah, I could see where, it definitely adds the pressure, and I could understand a company that decides not to pay. I mean, it's similar, with paying for kidnappings. You're paying the criminals. you're basically just encouraging the action further.
It's kind of like that don't negotiate with terrorists mantra, in a way.
Oh yeah, no, and I mean you're right in the idea that it honestly, like, does it make a big difference? Your stuff's going to be encrypted one way or another? Probably not. But I think the different idea is that they give them like 2 weeks to go and say, if you don't want this in the news and blah blah blah, well then just pay us now, right? Otherwise, that's when you see them publish it. So then you don't just have the bad guys to worry about, right? You've now got the stress of media outlets who wait for stuff like this to happen, harassing you. You've got researchers and every single person annoying the crap out of you. And when they publish it, like most ransomware groups, if they're, just trying to stay low down, they'll just encrypt the information, right? And then kind of annoy you about it to decrypt it. If they have, like, these groups are taking that information as well. So then you run the risk of they'll now give it to all the other criminals, right?
Yeah, no, I definitely see where, like I mentioned, I definitely see where the pressure is coming from on that side. Like, I see what's novel about this. It was just kind of had that question about, is it really necessary? And I guess you're pointing out, yeah, it does make a practical difference against those companies that might try and stand up to it a little bit.
Yeah, no, and that's kind of my, synopsis really, is just that I thought that this was interesting because of the fact that, like, I know lots of people talk about ransomware and stuff and kind of understand how it works, but I don't know. I just thought it was like old school gangster type stuff where it's like, okay, I'm not just going to encrypt all your crap. Like, I'm going to make it known that I've encrypted all your stuff and your clients are going to hate you. Like, it's just
paying for protection, going with the protection racket of the mafia.
That's basically what it seems like. That, if you let your neighbors know that I broke your windows and I fixed them too, and if they don't want, like.
One thing I did notice just scrolling down the page a little bit is, they're saying that it should be treated as a data breach because there is unencrypted files being stolen. So, like, does that mean technically that under GDPR, any companies that operate in Europe have to disclose when they're hit by ransomware now? Like, I never really, like, I know GDPR is kind of a weird topic because it's pretty vague.
Well, even if the files weren't being taken, I think just the fact that they would have been accessed by the malware doing the encryption would be enough to warrant a data breach alert.
Okay. Yeah, it was just something like I never really thought about it. Like, obviously,
like, GDPR,
if a database is dumped on the web or something, then that constitutes a data breach. But just
it's a breach when it's accessed.
Yeah.
So what exactly happens from there? It takes time to figure out what exactly happens in an attack, to figure out what was actually taken and stuff. But at the moment it's accessed, it's breached. At least as far as I know. Obviously, I'm not a lawyer. We're not lawyers on here, but
he's providing lawyer advice right now. That's what I heard.
Yes, that's it. You can take this, run your company based off of my advice. I highly recommend it. But yeah, as far as I'm aware, with GDPR, as soon as that access happens, it's considered a breach, and we've kind of seen that with, with that shop. I think we talked about them a few episodes back. That one shop that got compromised, and the white hat hacker who was acting fairly dark was kind of trying to leverage that, saying they needed to disclose the breach because he had access, regardless of the fact that he hadn't made it public yet. Yeah, Ona, did you have anything further to kind of add on that?
The only thing I would say is that, to throw a little shade, I think talking about GDPR and certain things, I'm not saying that companies aren't reporting it, but I do get this feeling that, because I've looked into some of these compromises and stuff like that, I'm very comfortable saying that there's probably some companies who aren't reporting like they're supposed to. I can't name and shame because I don't know. 100%.
Oh, for sure. I think there's part of it's just people aren't necessarily aware yet that they need to be reporting all the time, or at what level they need to report at. And that's not an excuse. It is one of the things I appreciate with GDPR is I do think, companies need to be more responsible about disclosing when information's been breached. So I agree with GDPR kind of pushing that, although I do realize it adds a little bit extra work for like the small businesses and stuff. But yeah, I definitely agree. There are going to be companies that aren't necessarily alerting on the basis of a breach. Part of that's going to come down to being able to detect the breach. Small business isn't necessarily going to have the same skills to actually detect, hey, they've been breached. I do think this is an interesting case because you were mentioning about it taking months to decrypt. If it's taking months to decrypt, it's probably taking a while to encrypt also. They're probably sitting on there for a while. This particular page from Bleeping Computer mentions that attackers were likely on the network for weeks.
Yeah, and I don't want to interrupt Spectre. I know he probably had something to say, so if you wanted to throw your hat into the mix real quick, Spectre. I did have a response to that, though, Z.
Okay. What I just wanted to say was with the GDPR point specifically, even though it technically violates GDPR not disclosing if these kinds of breaches happen, the problem is how much is it actually enforced? I don't have the data laid out for that, but I imagine they're probably not really aggressively enforcing that.
So actually, GDPR does have some bite. I wasn't expecting to name any particular instances, but there have been some significant fines around GDPR. So I would say that it does have a bite.
Okay, fair enough.
I couldn't say in particular.
I wasn't sure.
Because, I mean, there's also the case of if they don't alert that there's a breach, how do you even find out that there was a breach? I mean, depending on the type of criminals that actually did the breach, they're not necessarily going to be dumping it, or how it gets used might not be clear. So, I mean, I'm sure there are companies that can get away without reporting because the criminals just have to kind of keep it quiet that they had the data from this source, or you couldn't actually isolate what the source of the information was.
Yeah, no, that's probably a fair point. And I think, it does have a little bit of bite. If you look at Facebook, and I think even Google have been sued based on GDPR, or fined, I should say, not sued, but fined based on those. So, I mean, it does have an impact. Now, like you kind of talked about, Spectre, how big of an impact? Again, a mom and pop shop, are you going to go drag them through the mud and stab them in the leg? Like, how dare you? Who knows how deep it really goes if it's not a big company. But, to kind of summarize on one point, Z, it does happen that most of these campaigns, and ones that I've even seen, it doesn't just happen overnight. Like, oh no, I went and walked away for coffee and my whole network is completely encrypted. Like, it doesn't, to my knowledge, I haven't seen anything like that. But the problem is usually a lot of these companies, I think even there's I don't know off the top of my head, maybe I can provide a link. There was some government agency, I think something with the power grid in South America, that basically like gigabytes, if not terabytes of information was siphoned out and stuff like that. So all these people don't have any cognizant idea of like the initial stage, which is usually the loader, right? So these things start with like a very basic malware, or not necessarily basic, but one that's just meant to drop more malware, right? So TrickBot and a few other variants. Then it kind of sits there and scopes out the network. Then it's like multi-stages where they go and run things like I don't know if it was PowerShell Empire, but there was definitely a few things like Cobalt Strike, some of the stuff that like pen testers use. They'll go and like compromise all kinds of other servers and Active Directory and stuff like that to get as much access as they can. So normally it probably takes about a week, but there has been some research that have shown like some of these campaigns, the second they get a foothold through like RDP or something, it'll take them like 48 hours to map out your network and then drop like something like Ryuk, which then just encrypts everything. So long story short, usually if you have really a good setup, you can maybe catch this in the early stages, but unfortunately it doesn't seem to matter since the malware is done intelligently. I mean,
and that's kind of a wider issue in general. There's a little bit of, once you're through the perimeter, there's just trust everybody that's kind of inside the perimeter. And that's a mistake, I think, for a lot of companies to have that type of network setup, but that's generally what it is, especially on the smaller side. Once you're in, you're in. And then you kind of just have, maybe there, as you mentioned, AD and stuff, but like maybe there's a little bit more access control, but it's very soft once you're inside. But I think I do want to get onto the other topic before you have to take off. So if you're good with moving on.
Go ahead. Let's hear it.
Yeah, well, so the other topic is potentially here from Vice, hackers are selling a critical Zoom zero-day exploit for $500,000.
Zooming back into the news, of course.
Yes, of course.
Zoom.
You know what? So I'm going to say it. I don't know if I believe this. I believe the advertisement is there. I am not sure I believe. So you can put an advertisement up for anything at any price. I mean, I remember during the Greece, this was years ago, when Greece had some financial problems. Somebody put Greece up on eBay for however much money it was that the EU was offering. Obviously this isn't being sold on eBay, but so I believe that's there. I don't know if the market's really there at $500,000.
I doubt it. I don't think it's worth that much.
No, neither do I. And I mean, the big thing is, and we can kind of go into a further discussion over pricing some of the exploits, but the thing is, a Zoom 0-day, first of all, it sounds like some of these require you to be on a call with somebody. So it's not like corporate espionage where you're going to secretly get on a call. You're going to have to already be in there, and it's to infect whoever you're calling. So that somewhat limits the use to, you already have to be a trusted individual. But in terms of the lifespan of an exploit like this, the problem with exploits for something like, even Facebook or Zoom in this case, is they're going to get patched reasonably quickly as soon as you start abusing it. Whereas, issues like, a Linux LPE, everybody who's running Linux needs to go and do that upgrade. With something like Zoom, there's that centralized patch. If they patch it on the server, it's patched for everybody, pretty much.
Yeah.
If it's client-side, okay, maybe takes a little while. There's automated updates, though. The lifespan of those exploits just doesn't last that long. Now, to be fair, there's definitely a chance that prices are being pushed up just because everybody's all of a sudden using Zoom. So, I don't have, the hands-on knowledge to actually say, but I'm definitely skeptical of the 500,000 price tag.
See, part of the reason the only reason I could see it maybe being even close to worth that much is because we have, as we've talked about in the past, we have seen governments using it. I think the UK government was using it for a little while. But that being said, due to all the Zoom issues that we have covered in the past as well, we've been seeing governments actually being recommended to and moving away from using Zoom as well. So while it has gained popularity, I think it's starting to lose some of that popularity, especially in the potential targets that you'd want to hit with spending that much money on it. I could see it maybe being closer to 50 to 100K, but 500K seems way outlandish.
It really does. I mean, even so, I can't think of too many other companies that will advertise the price that they're buying exploits at besides 0DM.
Yeah.
But 0DM, their web stuff, generally anything that's touching on the web, they're paying, up to $10,000 for stuff hitting the web. That includes compromising the mail servers in particular. Well, no, the mail UI, I guess, technically, because it's round human horde that they're paying for.
I was going to say the only thing when you 0DM is a pretty good baseline. The only things you're looking at in the 250 to 500K range is either all server tech or browser and mobile RCEs, and that's all you're getting.
Yeah, and to be fair, at the 100,000 range, they do have WordPress RCE, cPanel Plus. But again, it's not desktop applications like Zoom would be. It's not a browser. So, I mean, I could see why, somebody really desperate for a Zoom thing might pay more. That's why I said, because there's that could be pushing the prices up. But just using kind of the knowledge that we have about 0DM, and 0DM is gray market, technically. It's not black market pricing. But that's kind of the other thing. When you're talking about the government's usually buying gray market, as far as I'm aware. I don't know if, Andy, if you want to correct me on that. But I believe the government's usually going to buy from brokers who are going to buy kind of on the gray market.
Yeah, normally, so the way it works in my understanding, and this is in fairness, I'm not a government, that buys exploits, so please don't, quote me on this, but to my understanding and people I've talked with, the government normally, yes, buys from third parties so that there's less of a risk, right? So that if I go, let's say, normally they'd go and buy through 0DM or maybe 0-day initiative. I don't think ZDI offers that. But yeah, they go through a third party that then will go and find actually those things on their behalf. That whole point so that they can kind of even distance themselves more. There's a whole reason that you have to go through all these compliance checks and crap for selling to the government. So I assume, for the most part, yeah, they're not going just straight to the hackers and stuff.
Yeah, well, and the reason why I brought that up, though, is just because that kind of indicates that the people that are buying off the black market, they aren't the governments that are targeting people. It's going to be the kind of criminal, say, organized crime, perhaps, which, again, the demand there seems more like exploit kits.
Well,
corporate espionage, I think, is the other big area.
Well, and I would caution, I have regular fights with people about this, is that they'll go and say, well, just because it's only worth this much in real life, right, amongst exploit brokers, it's got to be worth double that in the underground or some nonsense. You're actually, I usually find that it's worth less in the underground because it's not like most cyber criminals, dude, are spending $500,000 for an exploit. That's insane. They can't make that much money, or if they can make that much money back, like it would never be for something that has this little utility. You know what I mean? There's no full chain. There's it's only working for, you know, one platform. Like, and they didn't even talk about which versions of Windows, which versions of Zoom. So like, I don't see most of these things. Like, even when there were some supposed Windows exploits, right? RCEs, I was seeing them being offered at like 50K and craziness like that. Whereas they're obviously worth a lot more in the exploit broker stuff. So
yeah,
I think
I would definitely agree with you. Like, my experience with the black market, which has been limited, but is that it's generally offering less, not more, unless you have something very, very particular, I guess I'll say.
Would it be fair to classify the black market more as less exclusive selling, but selling to more people, and that's why it's valued at less? So even though it's valued at less, you could potentially be making more money in the end because you're selling to more people, but because you're selling to more people, that bug is probably going to die a lot faster too. So I think that's like one of the bigger differences between the gray market and the black market. Generally in the gray market, like if if you sell to like Zero DM or something like that, they're going to want exclusive access to that. You know, they're not going to want you to go sell that to another exploit broker.
Though I believe
generally.
Zero DM themselves,
they do, yeah.
They don't sell it exclusively, but
yeah. But generally, when you're selling to a broker, you're going to be selling it exclusively. Whereas when you're selling it on the black market, I think there's less of that exclusivity. So while it's true you are selling it like it's valued at less, you are potentially making more, but it's probably going to die faster too. So that's why I think that's partially why governments probably don't even touch the black markets. Is because they want that exclusivity.
Yeah, so in chat, Razzie Wu mentions IMO, this 500K article is more of an ad for Vice to show they're down with current events rather than a call for Zoom user awareness. I mean, yeah, like this isn't really about Zoom user awareness because this isn't going to impact most users of Zoom. Anybody that's buying an exploit for $500,000 isn't just targeting the user base at large. So it's definitely not just about alerting people to the fact that there are Zoom O-days out there. In terms of Vice, I mean, Vice, they're a little bit, I'd say, sensational and biased in some of their reporting. That's it. The reason why I think we want to kind of cover this also is it was picked up by more than just Vice, of course. But I mean, Vice itself, I don't immediately trust what comes out. I mean, they used to be do some interesting stuff.
They've fallen.
Yeah. But I think we can save that discussion for another time.
Well, there was to that point, there was a good quote I saw the other day, is that this article is basically a game of exploit broker telephone, right? Where it's basically like, you know, well, this person, I haven't actually seen it myself, but I heard that maybe it sort of was like this, where I don't even know what the hell if it, you know, like you can't even tell where this really came from. And the other part is like their whole article turns into a whole, but RCEs have sold for hundreds of thousands of dollars before, and like, you know, they have 17 other links to other Zoom articles that they've written. And my favorite part though, for anyone reading this, let me see if I can find the section. If you want to Control F, there's a quote from quote unquote you can look for perfect for industrial espionage. Some a veteran of the cybersecurity industry calls it perfect for industrial espionage. I was like, why would you even say that?
The Windows 0 day is nice. A clean RC said want the sources. Yeah.
A nice clean RC. I mean,
is nice a clean. So like that's, you know, probably a mistake there, but yeah.
I thought that was a great quote to summarize how nonsensical some of this was, because it's just some veteran, right? I don't even know if that was someone that they've interviewed that we get to see them.
To be fair, I can understand like some veteran not wanting to associate their name with knowledge of some of that.
Yeah, well, I mean that, you know, the quote was the best part, is that it seems like something that literally is meant to cause clicks, that you go and still like,
true,
you know,
yeah.
Oh, this is perfect for terrorism or some crazy shit. And you're like, why would you even say that? Like, why would you? Because like, dude, I can tell you my team and all these other like companies, they had to spin up nonsense, like little investigations to figure out, because of that quote right there, perfect for industrial espionage. Like, based on what? Because it's an exploit? Like, I just thought it was hilarious. I understood maybe where you could link the two together, but it's just a great quote that I want to start writing articles like that.
To be fair, actually, just a little bit ago, I did mention that, like, one place is, like, if you're going to use this exploit, like, that would, or it wouldn't really be too useful in the industrial espionage area, because you need to already be on a call with somebody for it. So, like, I guess you could use it, like, if you exploit somebody during, like, a sales call or something. Like, I could see something there, but I mean, you'd more, like, at least, again, I'm not, like, some experienced exploiter with doing, like, any sort of industrial espionage, but I can, like, I'd want to see something that could be used more for spying if you're going to talk about espionage like that. Whereas this is less that. Like, you know, if you could join a call without being seen, that would be something worthwhile for, that would be something that's perfect for industrial espionage.
I feel like that's what they misunderstand, is that, like, espionage isn't meant to be, like, obvious, like, something that would tip them off, you know? Like, that feels like, and I still, you know, I'm not deep enough into the exploit world. I really would be curious if someone could replicate, knowing that it has to take place during a call. That's got to be a certain call to, like, some type of media library, right? Some type of streaming thing that occurs when you call someone, you know, relating to VoIP or something, right? So
I mean, it could be similar. You know, we've seen some WhatsApp vulnerabilities. There's that one pre-acceptance vulnerability a while back.
Yeah, and there was the GIF one as well.
Yeah, although that
where it had the parsing.
Yeah, but the GIF one is a little bit different. But I mean, if you could do something like that with the audio library, that could be kind of where this sits.
Funnily enough, I mean, this isn't too related, but I'm pretty sure in the console hacking scene, one of the 3DS vulnerabilities that was used to jailbreak the Nintendo 3DS was actually in the audio library. One of the, like, ioctals or something for that driver.
So to jailbreak the 3DS, did you have to scream at your 3DS in a particular way?
I don't,
because that would be a really cool
that would be fun
exploit if it's like you scream at this pitch. So going back, you know, like Captain Crunch. What was it, 44 megahertz or whatever that was?
I don't think it was in the microphone. I think it was in, like, the for playing audio for games and stuff like that.
Yeah, well, I wouldn't imagine it was like that, but just mentioning it makes me think of some sort of exploit that you could do verbally like that, going back to the old freaking days.
Maybe there could be an Alexa one. Yeah, but I think we can move on to some news. The first one is how I reverse engineered the LastPass CLI tool. So this one is far longer than I expected it to be. It's a very long article, so we're not going to be covering the full thing.
Yeah, but essentially, and I brought it up not so much because I want to cover the entire thing, but just basically what this guy did. Sorry to just cut you off and jump right in, Spectre, but basically, what he did was he took the LastPass command line tool, which is open source, and he basically rewrote that as more of a library that you can use in Rust. And I think, Auntie, do you want to stay on for this topic, or since the first two are the ones?
Yeah. I'll stay on for this last topic, and then I'll hop off. So if you want to keep
all right, well,
yeah,
I'll just keep going. So. I mean, there's no point, I think, in talking about everything that he found. What I thought was interesting, though, was this was fairly consistent with what LastPass has put out in the past. So one of the big issues with LastPass is you kind of have to trust what they say in their white paper or what they say in their documentation is actually what they're doing. And of course, you can go and validate that by looking, you know, in this case, at how the command line interface actually works, how that software works, how it's generating the passwords, how it's using them, what it's sending, all of that. You can go and do that. So this is somebody that has gone and done that, has documented the process. And while I don't think he doesn't call it out, but it was fairly consistent with what LastPass has put out. And that's just a positive sign that what LastPass is actually doing what they claim to be doing. And I also just wanted to call out, there's definitely a misunderstanding as to how these cloud-based password managers work. I won't drop any names in particular, but I remember being on another Twitch stream, and the guy just meant, like, you know, if you're letting the cloud know all your passwords or something, you're just doing it wrong. or it was something like that, where you basically had the idea that password managers actually knew what your passwords were, and how LastPass works, how Bitwarden works, how basically any of the cloud or centralized storage password managers work, any of the big ones at least. Obviously, I'm sure there's some random one that's just implemented stupidly, but they don't know all of your information. They basically just store this encrypted blob that is only decrypted on your side. They have separate keys to do your authentication, to authenticate that you're allowed to see that blob versus being able to actually decrypt the blob. The keys kind of split up into 3 parts, stored in different places, and you're the only one that actually brings them together with your master password that's kept local. Long story short, basically what I thought was interesting here is just he found, a lot of consistency with what we've been informed about. And in theory, this is somebody else. Obviously, if you really want to trust it, you have to go look yourself, but this does seem to be kind of somebody independent coming to the same conclusions about how it's working, what it's doing, and just generally a positive sign. It does mention, reverse engineering. He starts with the source code of LPAS. So
yeah, I was kind of thinking
it's not reverse
not really
engineering.
Reversing. Yeah.
Yeah, but I mean, that wasn't really the aspect I cared about. I just wanted to point this out as something it's got the consistency there. Like, I'm a fan of these cloud-based password managers. I completely get why you would want to take it a step further and store it and use like a KeyPass or something, not use the cloud-based system. Completely fair. But the biggest concern are people reusing passwords. That's what you want to prevent. Make it convenient not to reuse passwords. So it's better that just kind of the general public uses something like LastPass than keeps reusing passwords.
Yeah, and the nice thing about some of those password managers like LastPass too is they allow you to use some stronger authentic like dual auth along with a master password. So even, there is that idea that a master password, if somebody can break your LastPass account, they do get all your other passwords, which could be a concern. But
that's a concern though
with the dual auth as well, because you can attach things like a YubiKey to it. I think that might only be available to LastPass Premium, but you do get access to some of those other more secure authentication methods as well with password managers, which I think is really nice.
There's always a risk though that LastPass itself will be compromised and those vaults will be leaked, which aren't protected. Like there's no way to kind of add the MFA to the vault itself. Like that's kind of added by LastPass around making the request to get the vault.
Yeah.
So there's always that chance that something like that happens, and that's why just how they store it, the fact they don't actually store it, like how the keys all work, how they can't actually decrypt it themselves. Cat 3009 touches on what I was just saying. A nice solution for passwords is KeyPass with encrypted database in a Dropbox or cloud. And I mean, I get why people do that. There's a convenience aspect to using LastPass, to using some of the other systems. I agree though, like using KeyPass is going to be, it is an extra step of security. It's also an extra step of work when we're talking about kind of getting everybody in the masses using it. Something like LastPass is far more convenient than needing to make sure you always have that encrypted database around. That said, that is still a better step up, but at this point, I don't think the world's ready for that to be the default recommendation. It's not that I disagree with that recommendation, but I mean, you're deciding that you know how to store that encrypted database better than LastPass, who it's basically their whole goal is storing those vaults, among other things.
I think that was a good point I wanted to make. That, like there's lots of good hacky solutions you can do, like you can encrypt it, put it on a USB, dig it onto your house and stuff like that. But, kind of like what you're talking about, I think it's the convenience, if you want to get like regular users to actually use these things and not use, hacker 13 as their password over and over and over again. This is really the only solution I think that works for normal people. But I think it's good that like actually people like this are testing out all the tools available to this type of thing, because you never know who's going to be using what, right? If they use the CLI only.
Yeah, well, so I think part of this is so you can kind of use LastPass embedded in another application pretty much.
As a library.
Yeah, it's taking it as a library. I imagine LastPass didn't release it as a library pretty explicitly to try and prevent that from happening. Obviously, I think they knew like they couldn't totally prevent that. But I'm going to guess somewhere in their terms, it probably does disallow kind of fronting, like or whitewashing LastPass as your own service.
Which does make it kind of interesting why they would make that command line tool open source if they didn't really want that. I guess just for the transparency aspect.
Well,
I don't know.
I mean, probably. I mean, they document well enough. Like, you could reverse engineer from the JavaScript of the extension too. Like, it's not like it's hidden and stuff. Oh no, I just feel like it was probably an intentional decision not to actually release a library like that.
Yeah, that's probably fair. Auntie, are you going to be staying on for our next discussions, or are you going to hop out?
Well, I believe it's time for me to hop out, gents, but it was a pleasure as always.
All right, thanks for joining us.
Thanks, y'all. Have a good one.
Okay. So with that, we will move on to probably the biggest topic of the week, and that is Binary Ninja. We have it split into two separate topics because they did a blog post as well. So the first one is a blog post from the devs and talking about hitting Binja 2.0 hitting dev and what kind of things are dropping with it, as well as the HLIL or the decompiler, which we'll talk about next. But there's some notable things dropping that like outside of the decompiler as well that they mention in this blog post. So a few of those are they're releasing an official plugin for debugging. So they have some screenshots showing, their debugging front end. They have the register view and all that kind of stuff.
Yeah, so I believe they've already released this plugin. Whether or not it's been
it hasn't
used.
Been stable.
Yeah, that's
it's in dev.
what I was saying. But yeah, it's been released. It is kind of available there.
Yeah. And then some of the other like notable things they've dropped is a merge tool for collaboration and a new XREF panel, which is really awesome. That is one of my biggest gripes with Binary Ninja when I was using it last was the cross references panel was kind of annoying to work with. I think like you couldn't even really pop it out before, and it was very simplistic and basic. You couldn't really get too much information out of it. But their new one that they're doing, let me just go back to it. The new one that they're doing actually has like a lot of information. It has the type information in there, and it talks about if it's a data reference or a code reference. So I really like that new cross references view. I think that's probably like that's personally something that I've been looking forward to. So, I don't know if I'll really use a debugging front end, but I know there are people who, that was one of the biggest things where people didn't want to switch from IDA to Binary Ninja or Ghidra, for example, is that fact that IDA has the debugger and Binja and Ghidra don't.
Yeah, I mean, it's definitely...
It seems like that argument's kind of disappearing
It's a consistency thing, too. Like, if you just you get used to having the one environment where you're able to do everything. I mean, there is a nice part of that where having it built into what... Because I assume with the plugin, eventually we are going to be able to swap out what the backend debugger actually is, or perhaps you can do that now. I have not used the debugger yet. That'll be a big thing where you can use remote debug servers, start debugging stuff and other things. And it's just nice to kind of have that convenient, like the same interface across everything rather than needing to kind of like hack things together. I get why people want that. I don't know.
That could be really cool for me personally to look into too. Just like if you can implement like, a custom debugger backend and stuff like that.
Well, I feel like the odds are they'll get to the point where, it's pretty easy to swap that out if it's not already easy to do that.
Yeah. The main reason I think that would be interesting, just for me personally, is where I work on PS4 stuff. That could be like a really cool plugin to do. It's like a PS4 debugger through Binja. But it could be useful for like other IoT stuff too.
So it looks like they do mention using GDB servers, so then that means anything that implements GDB servers should be usable, I imagine.
Yeah, makes sense.
So at least that far is good. I don't know what they're using on Windows.
So I was gonna say it sounds like there has to be something for Windows because that is a pretty big user base.
Yeah, so I'm going to assume they already have support for various debuggers. Actually, I don't see it explicitly listed here. But I would have to assume they've already got that.
Yeah,
in
no,
place.
they have like WinDebug support or something like that. But yeah, we'll have to see. But yeah, not too much to talk about there, but it is cool just to see that it's not only the decompiler dropping, but there is also the debugger dropping at the same time, which is like two of the major things that Binge has needed for a while. So, talking about the decompiler, we'll jump into that as well. So Played CTF was happening over the weekend, and Vector35 actually teamed up with them, did like a little collaboration, and they dropped the decompiler on the dev branch just in time for Played CTF, and I think they also gave away 8 commercial licenses to the winning team of Played CTF as well. I'm surprised you haven't jumped in yet and corrected me, because I know it's probably supposed to be Plaid CTF, but
we already talked about that before the show, so I didn't think we need to break that up here.
Jump in.
That anyway. Said, gave 8 away, but it is on cloud, and I want to mention right up front, there is a little bit of an issue with the cloud one versus what you get with the actual product, what you get with the paid one. I did notice a couple differences there, and I think we're going to kind of jump into what this decompiler is actually like, because I think that's kind of something that matters here. I was definitely excited to see HLIL being dropped.
I didn't expect it this soon. I thought it was going to be another month or two at least.
Yeah, like it seemed like they were teasing it a fair bit. Like they upped the amount of teasing they had towards it in the last week. So I'm not entirely surprised. That said, I will say this drop, it did get me to go and buy a commercial license. Another big part of that was Idaho, complete disappointment. I just want to put my money behind a company that's actually trying to improve the state of things rather than just kind of being the status quo. Nonetheless, let's talk about the decompiler. Oh no, my initial thoughts, just really simple initial thoughts. I wasn't disappointed. I wasn't insanely impressed, but I wasn't disappointed.
Okay, so I mean, I've seen a few gripes about the Binary Ninja Decompiler. One of them is they went with a weird choice of just using strict indentation Python style and not using any braces for code blocks.
You know what? I hate that gripe though. So
you don't like that gripe?
So I'm actually going to pull up a screenshot from the decompiler here. Or, well, a few screenshots that I have.
Okay. While you're doing that, I will say that wasn't the only one. The other one was the variable naming. The default variable naming people find pretty weird and unintuitive. Just the way that it's like var underscore. I guess like Hexphrase kind of does the same thing, but like going 18_1, like they kind of just keep appending these indexes onto it, and it's kind of hard to follow. That being said, I don't know, I can't really come up with a better solution on the spot, but that is one other complaint I saw that was common across different channels.
I mean, I believe the 18 is the offset. Like when it's var underscore, it's the offset onto the stack.
Okay.
For where that was kind of like the first time it's initialized. So like there is some reasoning behind it, I believe. That said, when we're talking, so I pulled up this screenshot. This is from Rop Emporium's Bad Characters Challenge. Somebody actually on the RE Discord server kind of pointed out some other things with that particular challenge that I'll bring up. But in terms of the code blocks, so you'll see here they don't use curly braces around anything. They just do indentation style. So I can understand why people are like, oh, I don't like that code style. You're not writing this code though. You're only going to read it, and the reality is that adding those braces is purely because this isn't C. I mean, there's other things that make this not C. You're not writing this. You're only needing to read it. The only thing that those braces will add is empty lines. That's the only thing it adds. So I would rather, just like reading the disassembly, it's usually fairly concise and all right there. Those braces only are going to be adding empty lines that don't actually add any meaning.
I think it's just one of those things where people want to be familiar with, like they do equate decompiler with like C-like output, so they expect to see that, and when it's not there, it just kind of makes them a bit uncomfortable.
Yeah,
I don't really agree with that like gripe either. I don't think the braces are too important of a.
Yeah, I didn't even notice it actually. So I noticed it with one case where it was like an if statement, because I've mentioned that's one of my pet peeves, doing if statements without braces around it, like one-liner without braces around it.
Yeah, I remember you saying
we had a little discussion about that. I noticed it with that. I didn't even go and look if they were using it elsewhere, though. It wasn't until somebody else pointed it out that I even noticed. that it was doing that. That said, other gripes. One of the big things, if you notice, you've got the 2 for loops and then an if statement. ZXQ bracket, ZX.D bracket star bracket. All those resizes, actually, I think I have a better picture of that.
So that's basically saying 0 extended quad, 0 extended
yeah,
double word.
So it's all these resizings. But if you look at this other picture I've got here, in theory, so actually I'm going to take from CAT 3009, nice feature of decompilers is the ability to copy and paste code to C++ compiler. It should compile without errors. I don't know if I've ever actually had that happen with even IDA's output. Maybe you have. I don't think I've ever actually had some that will just compile immediately, unless it was like some simple, application. But so
I could see that maybe for
IDA
CTF
supports it, but I haven't actually had that work. Sorry, Cap mentions IDA supports it. My experience has been that hasn't actually been what happens in practice.
I was just gonna say in CTF challenges I could see it maybe where you're dealing with like a not a complex binary. If you're talking about anything real world though, there's almost no way that's gonna just straight up compile without you doing a bunch of stuff as well. So I mean I can kind of see that argument, but at the same time I don't know how many people are actually doing that.
Yeah, like I don't. I definitely I've tried it just for fun to realize the expected that definitely didn't work that way. If maybe IDA has improved since I last tried, because essentially what it was I tried it, it didn't work. I never really cared to try it again. So I mean, what Binary Ninja's definitely done here is they have not gone for a C style thing. They've mentioned the possibility of doing that before. Mm-hmm. But they very explicitly they're not going for C. With obviously these. So coming back to these extensions, so these extensions are happening in the assembly. It is actually there in assembly. You'll see the move actually making those different sizing extensions, but it does make it very hard to read.
I will say I would have rathered if they went with C style casting, just for a quad word, just do uint64t.
And
that'd be more readable.
This is something they plan to change. This was actually something brought up really early on in their Twitter feed, within the first hour of it being released. And they're like, yeah, we do plan to optimize some of that to do some. So that's something they're planning to work on. And that is something important here. This is the beta of it still. This did just drop on the development update streams. It's not the final release of it. I imagine regardless, they're going to keep working on this. That's why I said I wasn't super impressed, but I wasn't disappointed. This is a very promising start.
So one positive I will mention, I haven't checked it out, and I'm going to check this out on the stream, which I'll talk about in a few minutes. But one thing I have heard that this decompiler is better than both Hexraise and Ghidra in is handling some of the extended instruction set stuff like SSE. I've heard it optimizes that a lot better than Hexraise does.
So actually last night though, not so much extended, but did find that it basically doesn't support floats. I didn't take any screenshots, but I forget what the instruction was here that it was failing on, but it was just like a move with XMMs. With the XMM registers.
Okay, so I think that is one thing I've seen though as well, is that it does need to mature a little bit. It is missing some instruction register ops. I think compare and exchange is another one that doesn't really seem to be supported. So, but
it's a good
some
start.
Of the criticisms. But yeah, obviously this decompiler literally just dropped. Hexraise has been around forever. It's been around for years. Ghidra has also been in development since the 90s. So, this is considering this is a fairly new decompiler, it's obviously not going to be flawless. It's not going to be without issues, but it's going to get that maturity over time. And as we've seen with Binja with other features, they don't just drop something and then stop working on it. I imagine this decompiler is going to be worked on for years. It's going to be an ongoing thing. And as it matures, it's going to get better. And as an initial starting point, I think this is great. And it's an option out there for people that don't want to use Ghidra, but also don't want to pay like $10,000 for all the IDA licenses. What I mean? It's usable.
And I mean, this is also totally exposed through like the API and stuff too,
which is another big benefit. Yeah.
That said, I am going to pull out a few gripes here, a few other issues that we've noticed. So I pulled up the graph view. Now, this is what you'll see if you use cloud. And this is, I was mentioning earlier about how the cloud isn't quite the same. So this is that same bad characters, or what was the function called? I think it was like check bad characters or something is the function name from the bad characters ROP Emporium challenge. If you were paying attention on the video before, or if you can't see anything, what we see right here with the graph is we see a while loop, and we see the var being incremented at the base. We see those, we can see the two increments actually, because it's a double for loop, but it treats them in the graph view as while loops. Whereas in the linear view, which you do not get in the free version right now in cloud, it gives you the for loops. It gives you something that, in my opinion, is much more readable than what you see in the graph view.
That's interesting.
So it seems like it prefers to decompile as a while loop when you're seeing the graph, which kind of makes sense because those like parts of the for are happening in different areas, so it makes sense to show how things jump around in that. Whereas the linear view makes a little bit more sense to just show it as is. Like, I kind of get where that came from, but it is worth noting because I did see some complaints about not picking up for loops. And I think that's why. I think it's because for loops basically only show up when you're in the linear view.
That's really interesting. I never noticed that. But yeah, that being said, I do want to bring up that tomorrow night, probably at like 8 p.m. Eastern, I will be doing a stream looking at Binja, because I have a personal license. I don't have a commercial license. I'm not balling out that hard. But, I'm going to be looking at the decompiler and comparing it to Ghidra, seeing like where it's better and trying to check out some of the complaints that I've seen, see how much like merit they have and whether there's a way around it and stuff like that. So I am going to be doing a stream that's going to be exploring that tomorrow. So I do just want to shout that out, just in case I forget to shout it out at the end of the episode as well. So, just for anybody that's interested in that, I will be doing a stream about that, and we will probably be doing a more polished video that looks at it, without all the things that come in the stream. We're going to be doing a video on that too, so be on the lookout for that.
Yeah. So
that being said,
go ahead.
I was thinking we'll probably move into more of the CTF stuff.
Actually, I want to go on with one more really big issue, and that is
man, you're brutal. Okay.
Well, so this, like, I'm going to say this is probably, personally, I see this as something that's going to get fixed very quickly. But if you take a look at this check bad characters function, notice the start of it. The var 28 equals 0x62.
Yeah.
And the for loop just kind of uses the relative act. Like it's basically looping through the indexes for each character and for each bad character. If you look at the MLIL though for this function, you're going to notice something really important, which is that the MLIL has a bunch of assignments earlier on. It has the var 28, var 27, 26. It assigns the entire array because this is obviously a array being declared on the stack. So it's doing that initialization there as you call in the function. It's setting up the entire stack with all of the bad characters.
Oh, wow.
The decompiler completely optimizes that out. It is there in the MLIL, so like it knows it's there. So this seems like something that, because the actual loops only access these indirectly, it doesn't really associate them together. So it's a failure on their part. It seems like a failure that's more like an optimization thing where it's like, oh, hey, these variables aren't used, let's just not show them. It seems like an overzealous optimization that can be tamed back a little bit rather than a really significant issue with the decompiler, but it is there right now. Like, that is a huge issue. It just seems to me like it's something that can and will be fixed pretty quickly. But yeah, I did want to point that one out also, because like that's a pretty serious issue to be missing that.
That is a good example, though, of why you should never completely trust decompiler output. Always, and especially with Ninja, because you have access to those other intermediate levels. You have the MLIL and the and LLIL.
Yeah, which is what I love here.
You can go down to lower levels to see to catch stuff like that that's missed in the decompiler output.
Yeah, like generally speaking, anybody that's kind of looking at this is going to realize, it seems like something's kind of missing here. With how it's like you're going to kind of notice that it's just doing the offset access, and you can jump down, like I said, right to the MLIL or go LIL or the disassembly. You can jump to all these different levels and get more information out. Yeah. And I guess to end on a positive note, one of my favorite things, it's super small, but I just love kind of the fact that's there, and this happens in MLIL too, is they will preface the comparison, so like less than equals to, greater than, or whatever, with a U or an S, letting you know if it's a signed or unsigned comparison.
That is really nice.
And I mean, that's something you kind of lose when you go to C. It's just not there unless you know the types and you know how they're going to get upgraded, downgraded, whatever, to know how that's going to get compared.
And the reason that's really useful is like there are absolutely signedness issues that can lead to some pretty serious bugs and overflows. So if you're not, paying attention to the types of both,
it's a quality of life thing that's there. It's it's just right there. It's information that matters to you, that isn't really included in like C code that they get to do because it's technically not C what they're doing here. So like that is one feature that I do really like in here. It's super small, but it's such a quality of life thing that just they kind of understand how people are using their product.
So overall, even though we have highlighted a few of the gripes, overall it's definitely a positive. I think it's it's going to get better over time. It's a good starting point. I think overall, it's been well received. I'll say that. I think it was a cool idea that they dropped it with the CTF as well. Though I do wonder how many serious teams would want to switch up their tools like at the last minute, an hour before the CTF. But there probably were some, and they probably got some useful feedback out of that as well. So, I thought that was a pretty cool move. But Z, you had some stuff to say on Played CTF specifically that we can plug in here, moving away from Binja.
Before we move on to that, I will mention our chat again. Cat3009 mentioned, has anyone tried Realize? I feel like we've discussed not on the episode before, but I feel like we've personally discussed using Realize before. I haven't used it. I don't think you have either.
I feel like I tried it, and it was yet another tool that failed on large binaries. So
okay, yeah,
I don't want to say for sure, but I feel like I've tried it before, and I wasn't happy.
Yeah, I remember us talking about it. I definitely it was, I think, before we even planned to start the podcast, like sometime last year or something.
Yeah, so, I will preface that by saying it could have gotten better for sure. Maybe I'll give it another shot. But, when I did use it, when you were talking about a year ago, it wasn't too impressive for me.
All right, so now that that's been handled, I want to just call out Plaid CTF. I mean, obviously, Plaid Parliament of Pwning, PPP, good team, always usually really good challenges. I wasn't really planning to play the CTF this weekend, but I happened to go and look and just kind of pulled it up early on and shortly after it started. And I saw a web challenge for 500 points, and the only other 500 point challenges were 2 pwnable. So that immediately caught my eye. I dumped like 16 hours, possibly more, of good hard work into that challenge and could not solve it. So I just wanted to kind of call it out. It's catalog. I don't know if they release their challenges. If they do, that would be a fun one to go back to. The solution's actually pretty cool. Like, I did kind of figure out by the end how to get the solution. I just didn't get it working. But it took advantage of like a new Chrome AD feature, using deep linking, using that to kind of exfiltrate information. Sorry for some spoilers. I don't want to go into too much detail with the spoilers, though. I just wanted to kind of call it out. It was an interesting challenge, and while I didn't look at anything else, odds are a lot of their challenges were good. If they do release some, check it out.
Did you see any, I know you've
Nobody
known some,
solved that
CTF
challenge.
Players. Well, I was going to say, I know you've known some CTF players in the past. Did you see any opinions from them on the CTF overall?
I haven't really asked around or anything. I mean, PPP's general, like, Plaid CTF's usually a very well-regarded CTF. I have no reason to think
that's fair.
People would have a negative opinion about this one.
The only reason I say that is, as time has been going on, I haven't been following CTFs too closely for a while, but the ones that I have tried and, seeing opinions of people who have been playing CTFs, it's been generally found that CTFs are becoming more and more gimmicky by the year. They've kind of run out of tricks, and they're trying to use these obscure things that almost nobody would know, and they just have to like Google some get lucky basically with a Google search term.
Yeah, so I mean that's
so
kind of the
I was
thing.
Curious if Plague was going that direction too.
Yeah, so I mean that's definitely the thing. I've stopped playing CTFs a lot now for that reason. Also, is like years ago, and I actually even said this on one of the podcasts that I recommended playing a CTF, but the more I've really thought about it, the more I've realized that no, like current CTFs aren't that good. Now, war games, the kind of long-running CTFs are still great for learning from, but the competitive CTFs, as he said, they've become a lot more gimmicky. That said, with this one, like I said, I spent like 16 hours and I never felt frustrated with the challenge. I never felt like the challenge was unfair, and that was actually really impressive. Because usually if there's a web challenge and like I'm banging my head for that long, odds are it's some sort of guesswork or something, but I was always finding little things that I could maybe abuse. It was just coming up with how to work everything together. You had to chain a bunch of issues to kind of get this one to work. But they included enough information to kind of lead you towards understanding what you need. Like I mentioned, use that Chrome 80 deep linking thing. But they explicitly mention like it's being viewed from Chrome 80 with uBlock, whatever version. So you go and you look like, okay, what's in Chrome 80? Why aren't they using Chrome 81 or whatever the latest version is? So like they had enough there in terms of the hints to drive you towards the solutions.
Okay, cool. I was just wondering because that did sound a little bit gimmicky when you were first describing it, but now that you've said that they gave those hints and stuff, I never felt like it was too unfair. I could understand why somebody would look that and not think to look at Chrome 80. Just think, okay, it's on Chrome, whatever. So, things Chrome fixed. Don't matter, or be aware that Chrome's a little bit different than Firefox. Like I could get why somebody wouldn't get that step, but they did include that information. And I've kind of learned with a lot of CTFs, you've got to read the descriptions. Well, in this case, the description actually, they explicitly said there's no hints in these big, long-winded description, but everything else here is what you need to worry about. And it was in that other section that included the Chrome 80, that included other things. So we can move on to Riot Games. So obviously, if you follow the gaming world at all, Valorant's been kind of blowing up, and one of the reasons it's been blowing up is it's almost like a Counter-Strike clone, but it addresses a lot of the complaints that come from Counter-Strike players, and one of those is cheating. So they're trying out a new AC called Vanguard for Valorant. And the AC's had some controversy over the last little while, some stupid controversy, I'll say, in my opinion, because it's a kernel driver and it's loaded at boot. It's not loaded when the game is launched. And they do that to try to, that way they capture the state. They load it basically before any cheat would be running.
Yeah, and that's a key thing going. Well, I don't think we want to dig too deep into it. I will mention, they load early on because the earlier you load, the earlier you're able to, the harder it is for cheats to get in there. Whoever loads first is going to be able to control kind of what gets reported, basically.
Yeah.
So it is a cat and mouse game at that level. And they've had a lot of, as Spectre was saying, a lot of complaints coming in about, it's always running there. And there's been complaints about the Chinese aspect, or, they've got some ownership from Tencent. Yeah.
Yeah, Riot's owned by Tencent, so.
Owned or partially owned?
I think it might be fully owned. I think Tencent bought them out, but I'm not, I don't want to say that 100%. But either
way, this is just the bug bounty is here for $100,000 for code execution on the kernel.
Yeah. Now, I will say it's quite a nice payout, but one thing you should consider is anti-cheat, you don't have a lot of attack surface. it's not like there's just not much you can really hit from an attacker standpoint. So while that 100K number is big, it is big for a reason. And that 100K is also for a 0-click. When you start talking about a 1-click, you're looking at 50 to 75K. And when you're talking about a, more than 1-click, just an LPE.
Does it mention 0-click here specifically, actually? Because I only see code execution on the kernel level. I don't see it saying 0-click or anything.
It says network attack with no user interaction.
Oh, fair. Yeah,
so
I was looking at the subcategory.
Yeah. So, they have those levels. So, 25,000 less for for an info leak.
Yeah, and the biggest attack surface is probably going to be that local privilege escalation.
Yeah, exactly.
And I'd say that's one of the biggest risks, really with any driver. Drivers are notorious for having issues, so using them for LP. And to be fair, 35,000 is still a pretty good payout for LP.
Decent. Yeah. But I just wanted to point that out for anybody who, might be hearing this and go, oh, okay, I'm going to look at Vanguard. That attack surface is definitely limited. So just, keep that in mind before you jump into it, I guess.
Yeah, that's a good point. I actually, when I was looking there, I just looked right at the subcategory and didn't even notice the 1-click there on the side.
Yeah. So we have a bit of a last minute addition as well, but a little while ago, can't remember exactly which episode, we talked about Google VRP, their vulnerability research program. And so they've got a grant out due to the COVID-19 stuff going around. So it seems anybody who submitted at least 2 remunerated reports from 2018 through to April 2020 will be eligible for a $1,337 research grant. So, if you've submitted 2 reports, or I'm guessing towards till the end of the month, you can still submit reports. So, because it does say April, it doesn't say April 20th or anything like that. So, anything from that
could
time
be start of the
April,
month, though, too.
It could be, yeah. It's not
the usage of
it
through April, though, does seem to indicate later in April. But regardless, go ahead.
But yeah, basically, it's there. Anybody who has submitted them or wants to submit them, if they still take them, can get that research grant. It's not a ton. It's $1,300, but it's something, And I think that's pretty cool that they're doing that. I think that's a good move.
I mean, that is, I think, more than the U.S. stimulus check, is it not? I think that's $1,200, and it's a one-time thing, so Google's offering more than that.
I know us Canadians, Canada.
Yeah, ours is $2,000 a month.
Yeah, it's a lot better than the US's, but obviously we also have far less people. But
it's also Canadian pesos, so keep that in mind.
True. It's probably only like $2,000 US for the whole year. But that is there for anybody who wants it.
No, it's nice to see Google doing that. I'm definitely not going to complain about them trying to support the bounty hunters. At the same time, this seems like one of those areas that wouldn't really be hit by COVID. If anything, they would have more people submitting bugs now because of it.
Yeah. Well, maybe, because you do have to consider, you
have more time in a sense.
More time, but there's also more family stuff going on too.
Yeah.
Yeah,
I could see why. It does feel like bug hunting is a little bit more resilient than other areas, though. I'm not complaining about them offering this. Obviously, there are going to be people that can't accept the money if they did the research while on work time. It'll be up to their company as whether or not they can accept that. So Google does also let you donate it. I believe they mentioned that in here.
Yeah, they'll match the charitable donations, yeah.
Yeah, we'll offer the option donate the grant to an established COVID-19 related charity, and within our discretion, we'll monetarily match.
So they could even double. They'll match it and pay on top of that, I'm guessing. That's kind of cool.
That's what it sounds like.
But just wanted to shout that out. It was a last minute thing. This literally just went out today. So
yeah, so I mentioned this in our Discord earlier, actually, sometime last week. Because Google the post wasn't public, but I did get the title of the post. I think they just accidentally published it and then retracted it, but my feed reader got it. I didn't get the content, but I was able to see the title there, and I had mentioned that it looks like they're about to offer something.
Yeah, so basically, join our Discord if you want those inside juicy details.
Oh yes, because we're going to get more.
That's going to happen every week, yeah, for sure. But yeah, well, yeah, just shameless plug.
Yep.
But with that, we'll move into some exploits. So our first one is on HackerOne, and it is a cache poisoning exploit that hits the WP-JSON plugin that can effectively DOS any endpoints on a WordPress site that's using it. So
yeah, key thing being using it leads to a DOS. I was trying to think of how this might be more exploitable. Like if you could use it for like some sort of information disclosure, like maybe being able to read some unpublished things. You can, like, because I was thinking because of, so one of the issues here is they use the access control allow origin header. They just repeat whatever origin the request came from. It sends back the access control allow origin with that origin. So I was saying you might be able to exploit that aspect a little bit. Basically, this is just an API you can dump like the public data. It's nothing too special.
Yeah. But basically what you can do there is you can force the server to cache those arbitrary origin headers, which then get echoed to other requests. And you can basically use this to force cross-origin requests to be denied.
So I'll mention, we've talked about that with like cache and confused a while back, like some of those different cache attacks where depending on what keys things are being cached on. So the origin header in particular isn't getting cached, or sorry, isn't one of the keys. Yeah, isn't one of the keys for the cache. So having a separate origin still ends up caching that request. So if you get your request from a malicious domain, when the actual domain tries to hit it, it gets the cache response that has this other origin.
Yeah, so I mean, from a high level view, it's a fairly straightforward issue. The fix was also fairly straightforward. It was like you said, you fix the way the cache is based on the origin, and it's now keyed based on the origin. That way poison requests aren't echoed to other origins. But you know, like you said, cache poisoning attacks are kind of like those cool ones that you don't see overly often.
We're definitely seeing more of them recently.
We're seeing more of them recently, kind of like the desync attacks, the HTTP desync attacks. So, you know, it's fun to cover those. But this one, you know, it's fairly straightforward. Earned a $550 bounty.
Yeah, fair bounty too for what it is.
Yeah, it was reported a year ago, but it just got disclosed last week. So we'll move on to Prestashop. So there was a critical CSRF to RCE bug in Prestashop. And Prestashop, I've never really heard of it before, but apparently it's an e-commerce service that allows people to host their own shops and stuff like that. And obviously, when you're hosting a shop, you're going to need to support images and whatnot. So they provide a file manager that allows various media file types to be uploaded. And one of the file types they allowed to be uploaded is SVG files, which allow JavaScript. So using that, you can basically get an XSS. Now, obviously, this can only really be performed by someone who can upload those SVG files, and most likely someone's not going to want to XSS their own store. But it also seems, for whatever reason, the file upload request didn't have a CSRF token on it. So you can just forward request to perform the action.
The whatever reason there, it's not uncommon because oftentimes the code that handles just kind of posts in general won't be the code that handles multi-part uploads. And that's kind of what's important here is that when you do this sort of post request with a file, it's being done with like URL. I forget what the MIME type is now, but it's just using like that URL encoded like key equals value kind of setup. Whereas with multi-part, it's definitely a more complicated setup. You give it the boundary, and then that's kind of used to separate. So you can send more binary data. You can send larger packs of that. So when you do a file upload, it's switching protocols a bit. Well, not protocols, but switching how the content gets parsed. And so in a lot of systems, it'll be different code that handles that, or just the normal post code won't end up handling that, so it won't end up checking the CSRF. It doesn't seem like that's the case here, but it's not an uncommon thing for uploads to be missing or not actually validating CSRF tokens.
Yeah. So then using that XSS, you can basically make a malicious link that they can click on, And they escalated it further to get RCE because they made it so the XSS can fetch the valid CSRF token to upload malicious themes through the admin panel. And through these themes, it's a zip file basically that contains all the files for it, and they allow PHP files in the zip file, and they don't check or like mitigate this at all. They just allow straight up PHP files to be included in the theme. So you just upload a backdoor PHP file that can execute commands, and you have command execution on the server. So it's pretty funny. I'm surprised that they have CSRF tokens for most requests, but they don't like bother
for
to
the
check
one
the
that mattered.
themes.
Yeah. Well, sorry. For the file upload there, that's when they don't check the matter. When it comes to the themes, like, I don't know how Prestashop does their themes, but having PHP files in themes for a PHP system isn't that unexpected. I don't know if Prestashop maybe doesn't if their themes are purely like CSS or something else. But I do know like WordPress.
PHP and file and themes. Like for that kind of service, I think CSS only would be a pretty good
the thing is,
compromise.
you want to be able to kind of customize your pages a lot, and themes can kind of be a replacement for plugins. Oh no, I'd say it's something to really consider before you allow that. But I mean, it is behind the admin panel. This is one of those cases of it just kind of being softer once you're on the inside. It's easier to explain once you're an admin, you're in a trusted position. Obviously, ideal cases just don't have that, but it's definitely not uncommon to allow it.
So this post is pretty cool. It's one of those multi-stage attacks. I did find some things a bit weird about it, though. For one, the post mentions that the bug is unpatched as of April 18th, which is when this post was published. And there's no disclosure timeline or information or anything like that. So did this guy just drop a 0-day on this service? Because I don't see anything about like responsible disclosure or anything. And the reason this is kind of worrying is something like a service, and you can get like userland code execution on the server. That's quite impactful compared to, even if you drop a 0-day for something that someone has to, like, it's a local thing they're running, it's a lot harder to hit that person. Where it's a centralized server like this, it's like so much easier to abuse by script kiddies and stuff like that. I don't
know if this is necessarily a centralized server. This is open source, so you can run this wherever.
But even still,
anybody
it's a server
can.
It's a lot easier to hit than just someone's desktop, for example. You know what I mean? Like, it's a lot more accessible.
Yeah. No, I just mean like it's also not going to be centralized in terms of patching. Like, people will have to patch their own deployments of it. I think it's kind of like WordPress, where you can run it on your own, or you could use the centralized one.
Yeah.
That said, I will also make a mention here that I did find it surprising that the post request actually did get sent. I say just surprising because I was sure that should be blocked by same origin policy when you try and set the content type header. I didn't think you could do that cross-domain. My understanding was that would be blocked by same origin policy because it's acting on a different domain, and while you can create like a form that would submit to another website, I didn't think you could do the XHR and modify that. That said, I did give it a quick test and it did fire off. You can't read the response, but it did fire off. So yeah, I was just a little bit taken aback by that. I'm not sure if that's a kind of recent change, but I'm sure that hasn't always been the case. I do maybe want to dig into that a little bit more because that opens up a ton of potential CSRFs if you're able to do that. Like I said, I ran it. It did work. You couldn't do the response, but it did fire the request without doing any sort of pre-flight. So maybe content type's now okay to edit. Maybe it has been. That said, it did take me back a little bit when I saw that because it seemed like that wasn't always possible.
Only other thing. Oh, sorry, go ahead.
Well, I was just going to say, because what I remember doing is trying to exploit JSON ones, where you'd have to kind of mess with to create what looked like a JSON body, because you can't actually send the content type JSON. You'd mess with the key value to be the start of your JSON, and then just kind of end it off with the equals being, or yeah, the equals and possibly like and characters and stuff would be just kind of appended on within the JSON, kind of. Like you just try and capture those extra things that get added to the normal sort of submission. So if you could just send like content type JSON, or well, application/JSON, then that just opens up a lot easier routes to exploiting some of those issues. So I do kind of want to dig into that a little bit more. So I'm just adding that as a bit of a caveat here. It seems like, this definitely worked. I gave it a try, but for some reason I don't feel right about that. I feel like I'm missing something.
The only other thing I was going to add on was jumping back to the disclosure stuff. Looking at the advisory, if you look at it, it was posted the day before this write-up went up. So Prestashop was given, if it was sent to them, they were given 1 day before this write-up went up. So, overall it's an interesting post and it's a cool multi-stage attack, but I do question the kind of ethics, I guess, of the post. It seems like this guy just dropped a 0 day, so,
I guess something that's maybe worth looking at is what the current version is. Maybe this just isn't...
I don't know. I tried looking and I couldn't find anything before like the last couple days, so... do they have the versioning information on there?
I'm just having a technical difficulty here.
Doing some live investigation.
It looks like 1.77, and what was the release here for 1.76?
For the actual issue?
Yeah, it's 1.76, and the current version's 1.77.
Okay, so it's possible that it's been patched and it's just like talking about an end day or something and just didn't bother to mention it.
Yeah, or that update's happened since.
Could be, yeah.
Which is another possibility, yeah.
Rapid fire update, yeah. But anyway, we can move on. So our next one is also on HackerOne, and it's a one-time PIN bypass. So, or rather, it's a disclosure of a one-time PIN. So it's in MTN Play, which seems to be a lifestyle type site with a variety of different things. I've never heard of it before.
Yeah, well, the co.za makes me think South Africa, so I don't think you travel down there too often.
Never, yes. But it seems the problem is the request which sends the one-time PIN also receives the valid one-time PIN in the network response.
Well, so how else would you expect the UI to validate it?
So you can just send a bogus request to get the valid one-time PIN. So it's a very straightforward issue, but it highlights just how, like, just because you have a one-time PIN doesn't mean you're automatically safe. You have to make sure that you implement it properly, and that's not even counting some of the
this
other
is a
issues
stupid bug, PIN. Honestly. Like, I mean, it's a stupid thing to have made. Unfortunately, the images aren't working for me, so I can't actually show what the requests look like. But it was literally an OTP
it worked
field.
For me when I last looked.
Yeah, no, it was working for me too. But yeah, it's literally the response when you send the request that ends up replying saying, hey, you need to fill out this OTP. It's literally just, this JSON blob. Well, not blob, it's JSON text. But JSON contains OTP as a field and the value right there in the response.
Awesome.
So you can see why that's bad, or you should be able to see why that's bad.
Yeah, I mean, it just goes to show that you have to implement it right, and that's not even counting the other issues that come with one-time pins. If you're talking, I think
that feels like they weren't even trying, though. Like, this is an issue that shouldn't. So this is probably one of those things where it got added to an object, and then they just replied with the object, not realizing what all was in it.
Yeah,
like somebody just kind of passed it in there, like it could have been added a little bit later, just like, oh, we need this value, it needs it here when it sends this object somewhere else too, and then just didn't remove it and didn't realize that got dumped. But still, I mean, it's an inexcusable issue.
And I will mention as well, it does seem like this happens through like SMS, And even if they implemented this correctly and, they didn't leak the one-time PIN, SMS OTP is not really that great because you have issues such as SIM swapping, taking a SIM and getting the victim's number, put it on your SIM, and you can recover the OTP. So even if it were implemented correctly, it still wouldn't be great. But, if you're going to add it, you should at least try to implement it correctly. So, we'll just add that as the dumb bug of the week, I guess, because that is probably like the most glaring, obvious bug that is in the episode, I would say.
Yeah, I would agree.
Yeah. So, the next issue I'm going to get into is the you added this
JSON.
one. Okay.
The JSON web token validation bypass. So if you're not familiar with JWT, the JSON Web Token, the basic idea is that it's a token you can issue to a user, and they can just kind of supply that with their request, and you can validate the token without actually needing to query the database. Like, the token itself will be signed by your authority, so like you're the one that signed it, you validate that it's a valid token, and it'll include things like grants information for like what they're actually allowed to do, or you can include a variety of things, but the basic idea is that it's just this really lightweight way to do authentication without needing to query a database on every page request. There are some downsides with that. I'm not a big fan of... there are a lot of ways you can shoot yourself in the foot using tokens. So while it definitely has some uses, you've got to be careful. It's a lot like crypto in general. You've got to be careful with it because you'd never want to issue a token that doesn't expire, for example. Back in 2015, a big issue was you could also just kind of create a token and insert the algorithm saying, well, what's the signing algorithm? Oh, I didn't sign it. Algorithm none. And give it all the grants you want. And if something just checked if it was a valid token and that it had the right grants and didn't actually validate that it was signed by who they expect it to be signed. Who they expect it to be signed by. Using the none algorithm is you can basically create your own tokens. So in this case, Auth0, they obviously, as most places have, they've disallowed using the none algorithm. I don't get why none algorithm was even included in the first place, maybe for development purposes. Stupid thing to use. Like, you're never going to want to use that in practice. Like, I cannot think of any legitimate reason to use none. Anyway, they banned none by checking if the algorithm's none, but they checked it in a case-sensitive way. So you could set it to none with a capital E, and it'll allow you to use the none algorithm again. This might actually even be a competitor for the stupid bug of the week, actually.
There we go, back to back. Yeah, I forgot you added this one somehow, so I was going to jump into the
I actually forgot I added it too. It's not in my notes.
I don't feel as bad now. But yeah, now I will jump into the Git issue. So this one's kind of a fun one, especially because it is in Git, which is used, people use it every day. Specifically, the issue is in the Git credential helpers. So, this basically allows you to store credentials so you don't have to enter them every single time. So if you clone a repo and it's a private repo and you enter the password for it and then you want to push updates to it, you'll probably want to store those credentials so that every time you push, you don't have to, enter your creds or whatever. So, they give an example. If you execute a command like git clone example.com, Git will call the registered helpers to see if you contain any creds for that domain. And then it'll attach those credentials to the outgoing requests when it's asked for authentication. The problem is, in their protocol, the implementation is actually vulnerable to a Newline injection. So you can do something like example.com /n host equals github.com, and then the credential helper will think it needs to fetch creds for github.com, but it'll send them to example.com.
Yeah, so I will just correct you slightly there. It's a question mark and then the new line. You're injecting the new line after the domain and as part of the query, or as part of the query string. Just want to point that out. Otherwise, it's exactly as you said. You're just able to inject, and the whole protocol there that uses to communicate with the credential helper is just that new line key equals value type setup. So host equals something. If you send it a second host, as Spectre said, you could get it sending the wrong creds to the wrong host.
Yeah. Now, part of the reason I said this was a fun issue and not a serious one is in practice, the attacker would have to send you that link and you would have to use it. That link would, like a link would like that would look extremely suspect. And I think I'd question anybody who fell for that, considering Git's user base. Most people who are using Git should be wise to not use suspicious looking links like that.
Yeah, let's just clone this repo. Oh,
Yeah,
why does this have a
it.
random domain in there? And what's going on here? Oh,
This
don't
is
worry about
perfectly
it.
fine. Everything's on fire. This is fine. But,
That said, or I think you're about to go into it, actually.
well, I was just gonna say, it's still an issue. It's kind of a fun one, but I don't think we'll see it exploited.
Okay,
But
so
what were you
actually, I
gonna go
guess
into?
you're not going to go into it. So they do actually show a case where you have a much more harmless looking URL, which is git clone, and you just have like example.com/git. Or example.com/ whatever the repo name is .git. And you can abuse that by using a 301 redirect. Though you have to, basically you can, if you redirect that .git request, whatever comes in there, to one of these exploitable URLs, you can do that, but you do have to include a username with it, which means it's it has to be targeted in terms of who you're targeting with it.
That is cool,
but they
though. I
do
missed
include
that
the
part,
case
so-
that you can use a 301 redirect to basically get the normal looking clone request to expose something.
Yeah, I'd actually somehow skipped over that part, so that's interesting. It does make it maybe potentially a bit more viable for targeted attacks, but like you said, you do need the username. So
Yeah, and the reason why you need the username is basically you would do the injection as part of the credentials part of the URL. So when you do like the https / username : password, which most people would never use that type of URL in practice, but it is used at times. So username at whatever the website. That's why you need to include the username there. You inject it into the username, which then limits who you can attack. So you need to know their username. But yeah, that's a practical attack. I think it's limited, it's targeted, but definitely doable.
yeah. So NCC Group is their articles we've covered quite a few times in the past, and this one talks about a local privilege escalation found in the component object model or COM services in Windows. So they actually found multiple vulnerabilities, but they found one in particular that they wanted to cover because, for one, it was similar to some of the other issues they found. And this one in particular, I think Microsoft tried to patch and they failed, and then they ended up exploiting it again, and Microsoft had to patch it again. And the other thing that makes it interesting too is the bug was actually created due to documentation being written incorrectly. So that's a pretty serious issue because that means that there's potentially more areas that have a very similar bug due to reading the documentation and expecting it to function like the doc said, even though it doesn't. So, they say even though this issue is fixed, there could potentially be more issues like it out there just because it spawned from, an incorrect documentation, basically. So they looked at various services running as NT authority or system, and they looked at servers that were executing in the Windows module installer service context, as I think all the servers running in that context are running as NT system. And the one they ended up looking at was the component-based servicing session. So part of what made this cool is they show a way that they first exploited it, and then they show how they exploited it again after Microsoft failed at patching it. So the bug was a arbitrary file disclosure in the ICBS session 10 interface. They found a bunch of various methods that are attached to that interface, but two kind of stood out, and that was the initialize and create package methods. So the initialize function needs to be called before any other methods can be called. You can kind of speculate that that's going to be the case just based on it being called initialize. And you can pass it a boot drive and a Windows directory as well as some other stuff. There are some restrictions. The Windows directory has to have the directory structure of a typical Windows installation. So it needs a users folder. It needs to contain certain components. I'm guessing by that they mean like DLLs and other folders, stuff like that. but an attacker with access can fake that structure. And the other thing they can do is they can also create symbolic links, which is then copied and is readable by the attacker, which can lead to arbitrary file disclosure. Now, Microsoft patched this last year in November. And what they basically try to do is, look and say, okay, this is a symbolic link. Okay, we'll just reject this. We're not respecting the symbolic link. So when they looked at it again after the patch, they noticed an error was being logged, but the service was still copying the target file. And this was because the way they checked if the file was a symbolic link, they used the getFileAttributesW method in the Win API to check if the attribute is set for the symbolic link. And this would work fine if the function worked how the documentation said it worked. And the documentation said if the path points to a symbolic link, the function returns attributes for the symbolic link, not the target file. And that turns out to be wrong. It returns the attributes of the final target file, not the actual symbolic link. So because of that, their check was essentially useless, and it would still end up copying that target file. So this was, again, finally patched last month. So it's just one of those cool things where you can see, just because an issue is patched doesn't mean it was patched correctly. So that's one thing. And then the other thing is, you have to kind of question the documentation sometimes.
Yeah, questioning the documentation. I just thought it was interesting that the two tools, the create symlink tool and the make link tool, had different behaviors there too. Because that was kind of what the difference there was. When a symbolic link's created with the make link tool, getFileAttributes does return the appropriate attributes. And includes that file attribute reparse point that they're looking for. But when you use the create symlink tool, the documentation was wrong. The documentation indicated that would do that, and it doesn't. I just found that interesting that the two different tools ended up resulting in some different. And I'm sure it creates a slightly different type of link because Windows has a bunch of different link types.
I was going to say, I'm not really a Windows person, but I think part of the issue is that there's different types of those. I think in Microsoft terminology, they're technically called junctures or whatever. But, there's multiple different types, like you were saying, and it's possible they missed that
junctions and links, I think, are technically different in Windows in terms of at least how they work. That said, that's getting too deep, I think. That's all I was saying, though, is kind of the same thing. I think what's going on, or part of what happened here, is that they were implementing different types of symlinks.
Yeah. So, kind of a follow-up to something we covered last week is What's a 10? Pwning vCenter with CVE 2020-3952. And those who tuned in may remember we saw a security advisory for a sensitive information disclosure in VMware's vCenter. But it was weird because it had a super high CVSS score of 10. Which is very high for an information disclosure. And we weren't exactly sure why. There wasn't any technical details out at the time. Z speculated that it could have been a credentials being leaked or something like that. And what it basically seems to be from this post is that information disclosure was undercutting the issue and was pretty misleading.
This is not an information disclosure. This is an authentication bypass.
Yep.
I mean, there's no way I would call this information disclosure.
They were downplaying it. Absolutely.
Yeah, and I think we speculate that they were probably trying to downplay something about it by calling it that. But yeah, I don't see how you even think that this is info disclosure.
It doesn't lead to info disclosure, but
well, yeah, but the exploit itself doesn't disclose anything.
No.
So the exploit itself, I don't know. Do you want to talk about it?
You can get into it if you want to.
All right. Basically, it just comes down to this VM-dir legacy access check. It's kind of two bugs. The legacy access check, when one of the permission checks fails, see if I can find the code or the relevant code.
By the way, you can just guess by the name. When you have legacy in the name, that's like a big red flag.
Yeah, so
there's something there.
Yeah, so the common pattern with the errors is it started off in this in the function. It'll set the D word error or DW error, but I'm probably going to keep saying D word. It'll set that to 0, and then if something fails, the expectation is that it's going to go ahead and set the error. It's going to say, whatever the error was. what ends up happening is during one of these calls, the VM-dir allow operation based on group membership. Basically, if it fails, it just doesn't set, or if it's successful, it'll set the DW error to 0. It'll say there was no error. But if it doesn't, if it fails, it just won't adjust that error.
It'll just return.
It just returns, which means it uses that default value, which is basically a fail open condition. So that's part one of the issue. Of course, you don't end up having any actual token. You don't have or anything associated with your LDAP session or anything like that. And then the other part of the issue is part of this legacy thing is certain systems would authenticate without actually having any LDAP session, no token being associated with them. And that would be these internal services. So they would just be granted root privileges. So that's kind of the high level look at it. Actually getting to that point was a little bit more complicated. Just trying to authenticate with bad credentials, of course, wouldn't work. That probably would have been discovered pretty quickly. But there was kind of an issue where it would set one of the internal flags a lot earlier than it should. Even if the authentication request wasn't successful, it would have still set this flag saying that you weren't anonymous earlier on. Which ultimately, you would basically do that, add yourself to the admin user group once you're kind of authenticated at that level, and then you can access vSphere.
Yeah. So one thing that...
Oh, I was just going to say, so this is like the opposite of information disclosure. Nothing's being disclosed.
Yeah.
Until you add yourself as an admin or whatever.
Yeah, but like you were saying, it's an auth bypass. One thing that was kind of interesting, though, was that first issue you're talking about. One thing I'll say about that, by the way, just as a quick interject, is it reminds me a lot of the Nintendo Switch bug. I don't know if you remember like the Switch presentation that was done at CCC a little while back. But they had a bug where they set the initial PID, I think, for your access. Like they did an access check for, if a process was allowed to access certain kernel driver stuff or something like that. And they checked if the PID was 0 for kernel because that has root privileges. So they ended up specifying a default of PID equals 0. But then on a fail condition, they never actually set PID to the correct one. So it's kind of like an uninitialized use. It's initialized to 0, but they don't initialize it to the actual PID.
Yeah,
and that's kind of what's happening here. They don't initialize the error from 0.
That's where I'd say like it fails open. A fail open condition is kind of like that, where when it fails in an open condition. That's kind of at least how I describe it.
Yeah. The other thing that was interesting about that issue was actually fixed 3 years ago in the code base that commit. But it never, I guess it never landed. I don't know, because they said it was fixed in August of 2017, but it didn't make it to release. So that kind of makes me question what's going on in the pipeline there, because that, the fact that they fixed it, they had to have known how much of a serious issue that was. So seeing that not make it to
not
release
necessarily.
And just sit in limbo for 3 years seems really odd.
They could have known it was an issue, but didn't really have a way to prove it was exploitable. Because they did kind of have to take advantage of that not being set to an anonymous bind before you could actually get through on it. Which does take a little bit of internals detail. And I mean, it could be something like somebody did that patch right before they quit. And then... the patch, maybe their boss quit or something and never really got approved, never went through the normal process. They didn't care to follow it up on it and just kind of got stuck in limbo.
Yeah, it just seems kind of weird, even 3 years is a
long
time.
I agree. It's a weird sign also. It's I guess it's not a code smell, but it's another one of those things. It's, what are they doing here?
Yeah. So, like we mentioned, the first bug was fixed. This demonstrates how a myriad of issues can lead to a takeover. It's, it's interesting in that regard. But what I was kind of curious about was, obviously the first bug was fixed, but I'm guessing the other issues, like the bind one you mentioned, still exist?
Possibly, yeah. I didn't see anything about that either. Well, so actually they do mention here that this is actually still exploitable in the current version. You just can't configure it to be in exploitable condition.
Oh, okay.
They do actually mention, because they mentioned that when they're trying to get set up.
So the issue is there, it's just not easily hittable.
Yeah, like basically they could directly call and change one of the configuration values, but they couldn't, like the UI no longer let you set the configuration in the insecure way.
Yeah, okay.
Yeah.
But yeah, we just wanted to follow that up because it is something that like really confused us at the time, and we wanted to know more. And now we do know more. We know a little bit more. And
We know that it was not info disclosure.
Yeah, we know that it was downplayed heavily by VMware.
Yeah, like that. Like I can't respect a company doing that. I mean, at least be honest about what your issues are, and I don't see how you like this is twisting it an extreme amount to call it info disclosure.
It does kind of suck. Like, I have lost a little bit of respect for VMware, honestly. Like, I've always liked VMware. I've liked their products, but
I mean, the sad thing is they're still the best like virtualization product to use
by far.
I mean,
like
even Hyper-V or
Hyper-V.
Yeah, I was going to say Hyper-V. Like VirtualBox can't compete. Hyper-V, yeah, it's less polished by far.
Well, Hyper-V is really good for Windows stuff. As soon as you start using it for Unix stuff, it doesn't compete with VMware. We'll put it that way. I've had massive performance issues on Hyper-V when it comes to Unix stuff. I've heard it's good for Windows stuff, but being able to run Unix stuff is a big part of some of the work that I do. So I don't use Hyper-V. We'll move on to Solaris. I honestly didn't even think is there anybody still using Solaris?
Probably legacy, more or less. I mean, so I actually thought Solaris development had stopped. I was mistaken on that. It's not. They haven't updated in 3 years, but they do still do occasional patches and stuff. Apparently, okay. I'm saying apparently because I didn't dig deep. I legitimately thought that the last release was like a final release. I didn't realize they were still doing some patches on it. And there's been ownership things, like it's passed hands a bunch of times. Either way, this bug is in the whodo or it's also in the W application.
Yeah, they share a code base, I think.
This example here does not actually go through exploiting it completely. It just shows basically that there is a bug in the heap, and they talk a little, or there is a buffer overflow heap based. And it basically just mentioned it comes out of the PS info structure, ends up being populated out of proc PID PS info. I mean, where else would you expect it to get the information from? But what it ends up doing at some point later on is, if I can find the code example, is it'll do a concatenation in one of the strings where it basically just adds a bracket, whatever your argument was, end bracket. And that's when it's filling in arguments, it basically just adds that in there if your argument actually started with like a dash space or something. So if you do that, it appends that little bit to the string. It doesn't account for that append. So if you have a max size string coming into that point, your buffer's already full, you can overflow by a maximum. In this case, like I think that'll fill up 15 bytes you can provide, and there's that argument plus the 2 brackets null byte, leading to, they mentioned specifically 17 bytes of overflow. 17 bytes is not large enough to reach other structures that actually kind of matter in there. So you can't get you can't get direct control flow. Sorry, you can't get direct access to the control flow with this. You can't overwrite anything that's like a critical control structure. You can corrupt the P child and P sibling, I think it is, which you may then be able to leverage into an exploit. They did not actually do that.
Yeah.
And so they do also mention some extra challenges there. Like I said, like that's the gist of the exploit. It appends the string and it doesn't actually count for that in terms of the string size, so it can overwrite. Easy enough to understand. Exploiting this might be difficult. It does start with privilege bracketing. It does have the priv proc owner set on it. It does drop that pretty quickly though, so you have a very limited time to abuse that. And your buffer is going to end with that bracket and null. which may or may not actually impact what you can do. Of course, you have to deal with ASLR still. A lot of work to still be done, but it's kind of, it's an issue in a pretty significant binary.
I could see this potentially not being exploitable just because you have so many compounding issues on top of it.
At the very least, you're probably going to need another gadget. You're going to need something for ASLR.
You would need an info leak.
Yeah, you need something else here. I mean, maybe you could turn this overflow into a read gadget. I don't know. I don't know enough how.
Considering all you can hit is pointers, like you're gonna need to be able to set about, or you might be able to do a partial override or something. But yeah, it'd be hard to hit.
Yeah, and they mention that, but it is a heap issue. I mean, if you want to play around with something, this might be somewhat fun to do that with, because it is. We don't know if it's exploitable. It is something that you'll have to prove you can exploit it with.
Yeah. So due to it not being proven to be able to give code execution, and with the set of restrictions, they only rated it a 2.5 CVSS score. I don't know if I entirely agree with that score. It's still a memory corruption, and it could be possible to get LPE, so 2.5 seems a bit low for me. That might just be my opinion, though.
Yeah, but so what they did is basically they gave it CIA is so confidentiality low, integrity none, availability none. You can't. So I mean that makes sense. CVSS doesn't always capture everything that's important.
Wait. Availability none. This could still be used to DOS, or well, I guess maybe not. It's not
that's
really
actually kind of. Well, saying, but like, you'd only be self-DOSing that request coming in. Like, you're not going to DOS somebody else.
Yeah, that's a good point. So, yeah, maybe, yeah.
So, I get it being low. The access vector is also considered local. Complexity is high. Privilege required low. User interaction required. Scope changed. So, I mean, CVSS doesn't always capture, it doesn't capture the potential of an issue. And there are issues. There are other options besides CVSS. CVSS is pretty standard, but there are other options that maybe try and capture the splash zone of the actual issue, kind of how far it will reach, and other kind of metrics that CVSS just doesn't capture. So no, I think 2.5 is fair given the limited access of this.
Okay. But basically, we're just going to use that to challenge anyone out there who wants to prove it wrong. Maybe you can try to exploit it.
Yeah, I'd be interested to see somebody actually exploit it.
Could be a fun write-up. Yeah. So talking about write-ups, we have yet another ZDI post. Like you were saying, another week, another ZDI post. This week's is about a privilege escalation found in the eBPF subsystem of the Linux kernel, which isn't super surprising. eBPF and BPF in general is pretty notorious for bugs. For those who don't know, eBPF stands for Extended Berkeley Packet Filter, and it essentially allows you to write filter programs which packets pass through. It's like an emulator for a mini instruction set, kind of.
Yeah, well, it's like a VM language, Java runs off of VM. I mean, I don't think it's not working like Hotspot VM or anything, but that's the idea. You have these limited instructions that work inside of the BPF VM, kind of.
Yeah. So because it's like a VM, it allows you to interact with registers, move memory within your own buffer, all that kind of stuff. And because of this, it obviously needs verification on memory accesses and all that stuff to make sure it's actually in bounds. And they use a verifier to do this, and this verifier is not perfect, and it's had issues in the past. In this particular case, the issue spawns from a discrepancy between 32-bit and 64-bit data. So jump conditionals are used for the 32-bit variants, and because of this, additional checks need to be done because attackers can control the full 64 bits of the registers and stuff like that. So to do this, they do a range check of the value between a min and a max. But if you have a minimum of 1 and a maximum of the max value for a 32-bit unsigned int plus 1, the range function just checks the lower 32 bits, and it'll see that they're both equal at just the 1 bit is set. And that's basically because the mask is only a 32-bit mask. And due to this, an assumption will be made that the lowest 32 bits of the offset will be marked to be known as just the 00001, basically. And this is a bad assumption because the minimum and the maximum are way further apart than the lower 32 bits would suggest. And this is an issue because the full value is assumed based on only the lower 32 bits when it doesn't account for those upper 32 bits. So you can basically break this assumption to break further assumptions. That isn't the whole story, though. You break the static checks that way. You also need to worry about the runtime checks, because in eBPF, because of all the issues, they added another stage called an ALU sanitation, which basically tries to perform runtime checks on values as well. So it does bounds checking. If you use a value, it'll check, will this hit the minimum or the maximum? And it'll check any arithmetic operation against the ALU limit to make sure the value can be safely added or subtracted without exceeding that range. But that also has issues. While it seems to work fine for one arithmetic operation, it doesn't work when multiple are chained together. So the example they give is if you have like a 4,000 byte buffer of safe memory, if you have two operations that add 2,500 each to the accessor, that'll be 5,000, which is obviously more than 4,000. It'll be out of bounds. But both checks will pass because 2,500 itself is within that 4,000 byte limit. So if you can chain them together, you can get an out of bounds read-write. And then that ends up bypassing the static check and the runtime check. So by chaining those two together, they end up getting a pointer up to hex 6,000 bytes before the start of their safe buffer's contents. And something else that's important there is that memory is not stored in its own heap chunk. It's stored in a structure. So that memory within the hex 6,000 bytes that they have out of bounds is completely deterministic. So that makes exploitation so much cleaner and nicer. And they basically found another member in the structure that they could corrupt to easily get an arbitrary write. And because that memory is so deterministic, they can also, they don't have to worry about ASLR. They can defeat ASLR. And then they just use that to smash the credential structure of the process to get UID 0. So, the exploitation of it is fairly straightforward. The actual bugs, it's kind of fun because it talks about, that discrepancy between 32-bit and 64-bit and all the math that goes into that. I do think they could have covered it a little bit better. Getting those details that I just said took a lot of mental effort to try to understand what they were trying to say. I think a diagram or something would have been really helpful here. But overall, the issue was really cool. And hitting anything at kernel level, especially when it's that complex and that subtle, I guess, is always fun to read about. So we wanted to cover it still.
Yeah, I mean, I'd agree with you on the write-up being a little bit hard to follow. And that it's a guest write-up also. I mean, it was, whoever, Manfred Paul from Red Rocket CTF, who did the write-up there. So, I mean, it's not necessarily reflective of how ZDI always is. But, I mean, it's still interesting to read, though. And, yeah.
Could be a fun exploit for anybody wanting to do kernel exploitation. One thing that is worth pointing out too is they say that it's commonly assumed that eBPF cannot be accessed from unprivileged users, which is smart because BPF, it's a VM. You typically don't want anybody to be able to use that because it is more likely to contain bugs. It's a very valuable attack surface. But it seems in a recent-ish kernel version, I want to say 4.5, they actually opened it up to be able to, so you can bind BPF filters to sockets. So that assumption that it can't be accessed from unprivileged is not a valid assumption on newer kernel versions. So that was another kind of thing of interest that can be pulled out of the article too. That being said, I think we'll move on to even more kernel vulnerabilities, our last set of vulnerabilities in the episode, and that is in Qualcomm devices. So this was a write-up by Zimperium, and it was basically two issues. One was a race condition, the other was a use after free. And they were both in basically the same area. They're in the QC-COM device.
Yeah, same area. I will mention that the race condition actually had, as they say, all sorts of memory corruptions depending on where exactly the race hits. Well, it's just given the one CV number, there's the potential for a number of different exploits because of it.
Not surprising. It's one of those ones where race conditions are kind of funny because the common way to defeat race conditions is using mutual exclusion, locking. And one thing that a lot of people don't really consider is all you need for a race condition to happen is to have one path that isn't locked. A lock is only useful if everyone who uses that resource has used the locks. So if one person accesses that resource without using a lock, then any other path can be erased. And that's what makes it so that's what makes race conditions so hard to prevent, is you only need one, and then the assumption is broken everywhere. So that's why races are so powerful, and that's why in this particular case, like you were saying, there is multiple ways to hit it. It's no surprise. So, basically, I think it has to do with how they interact with trust zone. They basically have this function that allows you to have a shared buffer between the kernel and trust zone, which, for people who don't know, trust zone, it's a trusted execution environment. In the chain of trust, it is higher than kernel. Technically, if you have kernel access, you should not be able to mess with anything in trust zone. So it needs that kind of mechanism to be able to bridge to communicate with trust zone. And
I do want to jump in before you go too deep with this and just mention there's this principle in programming: do not repeat yourself, or dry. I guess it's don't repeat yourself, not do not, but the dry principle: don't repeat yourself. And I think that kind of came into play with this issue a little bit. Part of this issue comes down to there are two different cases, as Spectre was mentioning, about this buffer that's used to communicate with trust zone. Basically, your application will allocate this buffer, this ion buffer, that you can use to communicate. And there's the function here that's vulnerable, is the QSECOM update command buffer, or the 64-bit version of it. And that will basically go and it'll translate pointers, is effectively the idea. Turn the pointers, take the buffer, turn the pointers into something trust zone will understand. And it handles two different cases in which the buffers need to be modified, and two different ioctls end up reaching it and end up calling it for two different handlings. And that's where I think dry kind of came in here. They tried to centralize what was more of an incidental repetition rather than actual repetition that needed to be prevented. Because where you can know this happens is when you start seeing a path where, at first you have exactly the same code pretty much. So, hey, I'm going to create a function that just, takes the argument in, and then you only need to update this function whenever you want to change it. And then when you see a flag being added, you see something else being added that will change that methodology, that will change how it works. That's when you know that you probably shouldn't have actually repeated that function. When you start adding those flags that make significant changes, it should be a secondary function rather than being just, combining it. So I just wanted to point that out, that I feel like that dry idea, like you do have to be aware of the idea of incidental repetition, where the repetition is there, but it's only incidental to what's going on, and it's not actually something that you should combine into one function.
Yeah, one of those things that contributes to this issue is this code would be fine in userland, because basically what you were saying with the two different types, they track it through this, you'll see it on, if anybody watching, you'll see it on the screen, they say data type. So they have this data structure that stores the type. The problem is that data structure is attached to the file descriptor. It's attached to the device. So, if you have two different ioctls that can change the type from underneath the other thread, that's where the race condition comes into play. Now, if this code was sitting in userland, this code would probably be fine. The issue comes in where in kernel, it's very easy to have concurrent access. And that's where a lot of kernel driver issues spawn from the fact that it's people who aren't familiar with the pitfalls that come with working in kernel.
Yeah,
they don't always consider that there's going to be concurrent access.
There is mitigation, actually. They do have some level of mitigation, I believe, against the concurrent access. It just wasn't sufficient here.
It's just not good enough.
Yeah, as you were saying, though, it's just one route. And I will say, if this were two different functions, though, you wouldn't be able to, the changing of the data type wouldn't matter. That's where I was getting at it from, was, by not the whole dry principle ended up kind of backfiring here because they have the one function doing two things. I guess that also comes down to separation of concerns. But if this were two functions, even if that changed, the function shouldn't have been even looking for that data type later on, is kind of what I was getting at.
Yeah. So depending on what you hit, they say this can be used to hit null dereferences or buffer overflows. The buffer overflows are obviously more interesting for exploitation. Null dereferences it's basically a useless bug nowadays. But the other one was a use after free, and this one I think was a little bit more interesting of a bug just because it's a lot more stable to hit.
Just before you switch, I do just want to kind of clarify the last bug. As Spectre kind of mentioned, if you can change the data type. So as I was saying here, where this function will change, or it will check the data type to decide what to do. So you can have a function that'll start with one data type, cause the other ioctl to be called, changes that data type, and it'll end doing the other functionality. I just wanted to kind of clarify that point, just make it explicit what the bug was. You can go on to the UAF.
Okay, yeah, that's fair. So in another function, which is also called from the same ioctl handler, is qccom set client memparam. And this can be used to set the request length. Now, obviously, this is bounds checked. It's not a super obvious, issue like that. It's not a low-hanging fruit issue. So if it's too large, it will bail with enval, which is a common error code for stuff like that. The problem is it resets the handle, but because the check fails, no other parameters are modified and they're not wiped out. So it will end up pointing to a previously set ion buffer, which has already been freed. So it's a classic use after free. After a lot of digging, I was able to find the patch. It probably took me like 20 minutes just to find the patch, but I will bring it up just because it does kind of clarify what the issue is if you're not familiar with the code base. I've just brought it up here. Basically, all they did to fix this issue was on error. They basically just mem set the entire structure to 0. So as soon as you go to use the next, the next iteration of that driver, I guess is a good way of saying it, it won't be able to access that stale data on the fail. So, it's just it's a classic use after free. A very straightforward fix.
Yeah, I mean, it felt like there was a little bit of extra work that needed to be done. I mean, nothing too difficult, but because it would null the I handle, and then another here called the set client memparam, that would end up setting the I handle again, and then it would be able to use other things. A little bit of extra work from just a straightforward UAF, but not much. You basically get that I handle reset, so then other things will start using it again because everything was checking I handle.
Yeah. So, good old Qualcomm. While I was looking into this, by the way, just to harp on it again, I've talked about it before, but I'll talk about it again. This issue absolutely still exists in certain, Android versions because of how fragmented the Android codebase is. I ended up finding, I think like Xiaomi or whatever, however you say that. I think their code base still isn't resilient to this issue. They haven't included the patch. So, you can see on the timeline here, the security bulletin was published and Samsung put in fixes and Google put in fixes. So on the Pixel and the Galaxies, it's probably fixed. But on a lot of other phones, this is probably still a 0 day if they're using a Qualcomm chip. So just be aware that this is not fixed on all devices because of how stupidly fragmented the Android community is in terms of trying to get fixes downstream. It's a nightmare.
Which is definitely something we've discussed before.
Yeah, for sure. Now, I kind of lied earlier. I said that was the last exploit, but I totally forgot that we moved this one up. So we got a blog post, another kind of follow-up to the SMBGhost vulnerability. So we covered the SMBGhost vulnerability a few weeks ago, but it was only as an LPE. It was said that an RCE remote code execution was possible, but we hadn't seen anything actually demonstrating that. The one that we covered a few weeks ago was able to get code execution, but they needed to use a local info leak vector. So
for anybody that wants to look that up, that was episode 36 when we talked about it.
Yeah, okay, good. Yeah, it's good to point out the episode number. I couldn't remember the exact number. So, you need the read primitive to know where to write to, because essentially the SMBGhost vulnerability, the way they hit it, it gave you an out-of-bounds memory corruption on the heap through an integer overflow in the decompress function, and you can use that to get an arbitrary kernel write. I'm not going to talk about that issue too much, just because we already covered that in depth on the episode Z talked about, episode 36. But what's important to note there is you can also hit other adjacent data with the memory corruption as well. And one thing you can hit, for example, is like pnet raw buffer or some other member that gets copied to a response, because your corruption is in the request packet. So two other members contained in the same header are pointers to MDL structures. And MDL, for those who don't know, it stands for Memory Descriptor List. And what's important about those is they contain physical memory pointers. So, when you're talking about kernel level, you have two different types of memory. You have virtual memory and physical memory. So virtual memory gets mapped to physical memory, and it's a lot easier to work with. Physical memory is the actual, the real address, if you want to call it that, that contains the data. And what's important about that is physical memory is harder to randomize than virtual memory. Virtual memory with ASLR and stuff like that is a lot easier to deal with, and that actually comes into play here. There's a reason they went with that MDL method. So they fake these MDLs in the k-user shared data because they're mapped to fixed locations in both userland and kernel. So you don't have to deal with ASLR. They're mapped in fixed locations. So they talk about some of the walls they hit with while doing this, and I won't cover all that here. Those who are interested are free to look at the write-up. But suffice it to say, they basically get arbitrary physical memory read through that MDL method. Now, I'm not experienced in Windows, but apparently hitting the page tables is a common exploit strategy in Windows kernel exploitation, which kind of makes sense. Page tables are pretty powerful to mess with. So because of that, Microsoft tries randomizing the address of the PML4 or page map level 4 self-reference entry, and they do that by randomizing the index. The problem is that happens at the virtual memory level. That doesn't happen at the physical memory level. So while the index is randomized, the physical address of that entry is not randomized. And that's why I was saying, physical memory can be really powerful to hit at the kernel level if you can do it. So it seems BIOS always had it at hex 1AA000, and UEFI always had it at hex 1AD000. So now they can basically get arbitrary read-write. And what they ended up hitting was the hardware abstraction layer, HAL. They essentially searched the physical backing memory of the HAL's heap to find the interrupt controller and smashed one of the function pointers for the interrupt controller. There are some other challenges even after code execution. Specifically, they highlighted they tried launching a user mode process, but they had some struggles with that because Windows userland uses control flow guard, CFG. But I don't want to go into that too much just because this is a pretty dense write-up, and I will say you will probably need some in-depth Windows knowledge to be able to fully appreciate it, to fully understand it. That's why, I don't want to go too much into those issues, partially because I don't have a strong background in Windows, and I don't think Z does either. So we can't go too much into exactly how all that works. I don't want to say things that are overly incorrect or anything like that. Overall, though, I thought it was a cool write-up. It's fun to see how an LPE can be turned remote using clever tricks like abusing physical memory like that. I don't know if you have any other thoughts on that, Z?
Yeah, well, I mean, we always kind of knew it was going to be an RC, that there was some way of getting that. That's what it was originally reported as. The LP was clearly just because they had the right. What can they, and this is what we talked about in episode 36, they did LP because they had the right and they had an easy attack vector to turn that into an LP by grabbing the token or whatever. I forget what they did in that one. But they had that method. So in this case, we just see, you're working on it. You go from that arb right, you get your read gadget, and keep moving from there, just expanding on that. It was a good write-up. You dropped this in, super last minute, so I didn't have much to say in depth on it.
Well, we had it as a shout-out originally, but somebody from the RE server wanted me to try to cover it more in depth, so that's where I tried to get, I wanted to read it more in depth, so that's what happened there. I will say, though, the actual issue that led to the arbitrary write, if you're interested in that, the post that we covered a few weeks ago does a way better job, I think. It has like really nice diagrams, and it makes it a lot more accessible. I don't think this one covered the bug as well as the other post. That being said, this one, I'm not saying like this one has a lot to offer. That method of hitting it remotely is very interesting, and obviously isn't going to be included in the LPE version. But just the bug details, you might want to check out that other post. But overall, yeah, I think this was a really cool post, and it finally demonstrated that it can be hit remotely, like MS were saying.
Yeah, and actually, I will just add the link into the description for the other write-up also. Just in case anybody wants it. It'll be down in the description here.
Okay, cool. So this time I'm not lying. That is our last exploit that we're going to cover, in depth. We will move on to some of our research stuff. So our research stuff this week is focused on fuzzing. Our first one is called iJON, which is exploring deep state spaces with fuzzing. Deep state, I don't think they mean like, the intelligence communities.
Oh, they might, but I mean, they're exploring Mario in this case, Super Mario Bros. 1, so, I mean, you never know how the Illuminati's using that.
You never know. So iJON is, I think it's basically supposed to be like an annotation mechanism that allows humans to guide fuzzers through problems that block a lot of modern fuzzers.
Yeah,
so on its own, it's not really a fuzzer, but it's something that interfaces with a fuzzer.
Well, so it's built on AFL. So it uses AFL, kind of modern fuzzing. What they kind of noted here is modern fuzzing. They exploit kind of neighborhoods of test cases. You give it a test case, it mutates that test case into something else roughly related to it. But there are a ton of cases that are just, the probability of triggering it randomly is just super small, very limited, if it's not actually kind of looking for that. So what they've introduced here is the idea of being able to do some annotation. So it's mixing kind of that code coverage guiding with limited value guided coverage, where it's trying to hit all the different values for something. And they provide kind of a good example of kind of the difference there. I think it's either in this or it's in their demo release. I don't see it here, so it must have been in the other thing. So what they kind of use as an example there is getting code coverage on some sort of Maze application, where all the application does is it basically just has a switch on if you hit WASD or, up, down, left, right. You hit one of those characters, it adjusts a single value, the X or Y up or down. And that's all it really does. By adding an annotation, they're just saying like, hey, also do a value guided coverage on the X and Y values, because getting code coverage, you could hit those 4 code paths up, down, left, right super easily. You're going to get complete code coverage there. But you also want to get that coverage of those all the possible X and Y values, which is kind of where they come in, adding in annotations for that. And so by adding an annotation thing like, hey, these values are also important, fuzz those. They found that they were able to get, they used Mario as the example there, able to get much deeper into it. In this case, like I said, they use Mario trying to beat the different levels. They were able to get much deeper in there and actually complete most levels.
Yeah. So if you want to see some of the implementation stuff of like some of the helper functions they provide, if you go to page 8, I think you had it up briefly, they had like a listing of some of the functions you have. So they have like iJON comp, iJON hash int, hash mem, hash stack, all that kind of stuff. And what you were saying with like testing on Mario, they also had a table on the 10th page, I want to say. Yeah, the 10th page. And they have like this little table comparing AFL on its own along with iJON and AFL and all the Mario levels it could solve. So like you could see AFL, it only hit 100% of the distance on a few of the levels, where iJON had hit it on all of the levels, basically. Or not all
most
of
the levels.
Yeah,
that said, like I'll mention, I mean, yes, Super Mario Bros. Does seem like a bit of a
weird benchmark.
Yeah, but so doing AI on games isn't that weird though, so I don't know. I mean, it is a little bit of fuzzing. Like, it's definitely a weird benchmark. It's not unheard of though. Because you have a goal, you have a very particular score, like you have something that can prove it's doing that. And it's just kind of a test case of, see, it's getting deeper into it. It's able to get that depth because we tell it to focus on these particular types of values.
It's a lot easier to visualize too. Like getting
Yeah.
program coverage is a lot harder to visualize for somebody who's not familiar with the contents of the paper
Well,
compared
it's
to like a
also
Mario level.
it's also like the difference between just code coverage, which is just the control handler, hit all the buttons, and you've got all the code coverage, versus kind of all the different areas. Also, like it illustrates the difference between what it's fuzzing for.
Yeah. So I did want to cover some of the observations they made before they got into their implementation details, which we just covered. I think there's some useful observations there. So one thing they found was code coverage is sometimes overestimated in what it provides, just because it'll keep hitting irrelevant state changes. And that's why they say like a human who can identify and guide those state changes might be more useful, which is why they provide those helper functions and stuff. Another thing they found was it might not be obvious to a fuzzer what can actually influence the state and to what degree. And the last thing was sometimes you don't even have good state information to work with. So one example they give is like magic bytes for that. AFL doesn't really know how to handle those. So all of these things, the paper authors argue could be improved by, including an actual person in that equation. So I like the idea. I do have some questions though. Like you were saying earlier, while Super Mario is fun, I don't think it should really be used as a serious benchmark. I'd want to see how this performs and works on larger complex code bases. They say they tested it against a test hash map implementation and a Maze and Super Mario. If they're going to be fuzzing things, I want to see how it actually works in the real world.
Yeah, no, they're all very toy
it.
evaluations.
Yeah, exactly. The other thing is, this seems to... For one thing, this wouldn't work for black box fuzzing because you need to insert these helper functions in the source code. So black box fuzzing is out of the question with this paper.
I don't know. Maybe you can instrument them in there.
Maybe.
I don't know if you can. That's purely speculation. Is if you can instrument them. Find a code cave, get that code in there, and then instrument the calls out from there. I mean, there's the possibility you could do that, but yeah, I mean, right now you do have to compile it in there.
So generally speaking, you need a white box fuzzing approach. And on top of that, this requires quite a bit of like human intervention, right? Like you have to have the human looking at the state changes, knowing where to put in those functions. They have to edit and recompile the source code every time they want to make a change. This requires a lot of human effort. And one of the big boons of fuzzing is to try to move away from doing that. You just let the fuzzer run while you do other stuff. Maybe you code audit while you have the fuzzer running, and you just kind of leave it sit there and forget about it.
But you do need to create the test cases, the test corpus for the fuzzer.
You do, but this requires even more effort on top of that.
Well, yeah, I was going to say, though, you can kind of relate to that. I feel like this is more where hybrid fuzzing would come in rather than annotations, using like the constraint solving to find those other paths that it's not being able to hit. I feel like there's maybe something to doing the annotations for what's of interest. Maybe in another way. Idea. Like I think there's something to the idea there for sure.
Yeah, I like the idea. I just question how much it's actually going to be like people are going to want to use it. You know what I mean?
Yeah, I guess we'll see. I question it too. Like, I don't think it's going to be the next big thing. I feel like that's kind of going towards more hybrid fuzzing.
Yeah. There was one quote, though, I really wanted to point out in the paper because I thought it was kind of a cool quote. It said, "Computers are incredibly fast, accurate, and stupid. Humans are incredibly slow, inaccurate, but brilliant." So that's why they're kind of marrying the idea of bringing the two together to try to find more issues.
Yeah, I do think like the annotations and a person who actually takes the time to do that, because that's a big thing when it comes to fuzzing. Like if you take the time to get the perfect corpus for testing with, it usually pays off a lot when you actually put the human in there to get some of that work done versus just automation. There's definitely work being done to try and automate a lot of that, but the human intelligence aspect of it, I think, is still important, at least right now. Yeah. Like, it still plays a big part.
I do, like, I do think whoever gets stuck in that job, though, of just writing the stuff and maintaining the fuzzer would probably suck. Like, I don't know if I want that as a job. It does seem kind of like dry work.
Well, it probably wouldn't just be, you know, a person who that's their only job. I feel like that would just be like you do that as part of your initial setup, ramping up on a project. You do some of that to decide where you want the fuzzer to focus on, set up some annotations or whatever. And then otherwise it's more or less as normal. It's, you know, part of that initial research phase and just getting up to speed on a new project.
So our last topic before shoutouts is another fuzzing paper. It's Pangolin, which is incremental hybrid fuzzing with polyhedral path abstraction.
It's a mouthful.
Yeah. So revisiting something we've talked about before, hybrid fuzzing. So just because it's been a little while since we talked about it, hybrid fuzzing is basically the idea of combining live fuzzing with symbolic execution to try to get better state tracking and overall coverage.
So not just that, but concolic execution is kind of important. So concrete and symbolic execution. I mean, you did kind of say that with the live running, but they take the live running, they take kind of the register values they get into functions, they take kind of all that live data, and then apply that into some constraint solving and using some symbolic execution on that concrete data that you've already gotten to help determine new seeds, to determine new mutations, and using that constraint solving to find ways into new paths.
Yeah. So they note that existing hybrid fuzzers can often get like super high overhead and lose efficiency. We've covered some of the issues with hybrid fuzzing before. Partially, you know, it can be hard to integrate with certain code bases because of you know, the challenges that come with it. But the problem that they point out is that the fuzzer is not able to keep track of the state when going deep into nested paths. So you end up with the state not really being preserved when it could be useful. So you end up with like these redundant recalculations of the state is how I read it. And I think the part of the reason they do that is maybe to prevent state explosion on the like concolic execution side of things, but I'm not entirely sure on that.
That's pretty much exactly why. State explosion is kind of the big issue.
Yeah. So that's where the incremental part comes in. The heart of their tool is to try to fix that problem. It does get pretty mathy because they talk about their own term, which is in the title, polyhedral path abstraction. I think it's basically used to try to help out and guide the SMT constraint solving and try to guide the mutation for code coverage. But it is, you know, when you're getting into constraint solving and stuff like that, you can see like there's these equations with symbols that most people probably don't even know exist.
Well, I mean, if you've done like intro computer science, I mean, you should get discrete mathematics in there, so you should be familiar with the logic symbols. That said,
I didn't do discrete mathematics.
Well, I don't think you did a CS degree either.
No, I didn't.
Yeah, I'm basically saying if you have a degree, it should be familiar. Which isn't a good level to be using. That said, I mean, this is out of a more academic conference. This paper was accepted to the IEEE Security and Privacy Conference 2020.
Yeah. So we can't cover too much of how that actual path abstraction and stuff works. But, you know, for those who are interested in the math behind that, it is there. The link will be in the description. But overall, it seems to be trying to solve a problem that has been plaguing hybrid fuzzing. So it seems to be trying to do something novel. So even though we can't cover it too in depth, we did at least want to mention it in the podcast.
Yeah,
do you have any thoughts on this?
I figured at least we could cover the gist of it here, being that it is trying to kind of solve that. Keeping some history, being able to kind of guide the mutation a bit through that history and guide some of the constraint solving. Like I said, just trying to solve some of the issues there. It is a take on it. Unfortunately, it was a little bit dense for us to kind of be able to give you guys the full details there. But, you know, it's kind of the leading edge of where some of that research is right now.
But it's basically the idea of using past information to predict future information. That's like the whole, I think the whole idea they're trying to go with. Yeah. Yeah,
well, the path abstraction interface is kind of their new novel area. It's kind of abstracting the paths that's taken through their away so that it doesn't need to know like the whole thing. It's abstracted away. That said, I think I'm just rambling with that.
Yeah. So we'll move on to some shout outs. So Z, you had a shout out with more fuzzing stuff.
Yeah, well, so when I first saw the paper, and I will mention, I forgot to mention when we got on iJohn, that actually came, that was mentioned by EXPY on our Discord. He's who first kind of linked that out, so I did want to give a shout out there. Sorry, I forgot to do it with that paper. But when I was doing that, I tried to find a good source for the paper, figure out like how old it was and things like that before I decide if we'd cover it or not. And I came across this really cool GitHub, which is literally just fuzzing paper. And all it is a collection of recent fuzzing papers. It's getting updated. So I just wanted to kind of share that. You know, if you're interested in the fuzzing research, it seems to have a good collection of them, paying attention to what's coming out. It's also just a good collection of fuzzing papers. I also want to just put a question out to the community and just ask if anybody's aware of a similar repository for exploit development, either just exploit mitigations or development or both or something along that. Because if that's not being done, I think that would be interesting to maybe start doing also.
There is one for kernel stuff.
I've seen kernel stuff. I've seen Windows stuff. I'm not sure if I've seen anything that's really just...
like more generic.
Yeah.
Yeah.
So I don't know. If anybody's aware, definitely let us know, either comments or, you know, hit us up on Discord, whatever.
Yeah, for sure. Or you can just you can tweet at us as well. That being said, I think that summarizes all the topics. I will reiterate again that I will be doing a stream tomorrow night, looking at the binary Ninja Decompiler, seeing how it compares, and looking at some of the common nitpicks and stuff that I've seen around it, trying to see how much validity there is to them and if they can be worked around. So that stream will be on probably around 8 or possibly a little bit later, Eastern Standard Time tomorrow. So, tune into that if you're interested in that. But we'll wrap up the show here. Thanks to everyone who tuned in. You can catch the VODs on Twitch right now or YouTube 24 hours after the stream. Also 24 hours out of the stream, we have the previous podcasts up on Spotify, Apple Podcasts, Google Podcasts, pretty much anywhere you can get a podcast. We have them up there.
Yeah, I will add, if you listen to podcasts somewhere else and we're not on there, definitely let us know. I do add platforms if we need to. Yeah, I think we've hit all the big ones, though.
Yeah. You can also join our Discord, like we were saying earlier, or follow us on Twitter if you want to get involved in the community. But if you're not tuning into the stream tomorrow, we will be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific. See you guys then.